I'm going to give my first talk, which basically is about some of the feedback we got recently from the industry. That is basically how we can reduce the energy cost and also carbon footprint in the pet food and aquatic industries, because as you know that our feed energy cost is going up, and also we want to reduce our carbon footprint in Aquafeed as well. With that, what is driving this? We all know that of course the prices, global energy going up, and of course our demand is also going up for the energy, and also we know that there's a shortage of water as well. There's a competition between, if you can see here, agriculture versus industrial municipalities, and some places clean water is very limited, and therefore we also know the weathers are changing, things are changing, therefore there's a lot of emphasis on that shortage of the water as well. Also, if you know that there is a corporate policies, they are trying to do it, basically sign the support to do it carbon credit, and therefore that will give them access to the sustainability, and energy prices going up every day. Therefore they want to get some profit from there. Therefore most of the corporate industries, if you can see that, they are already proactive, and what they're trying to do is they're getting some credit there. So if they can have some kind of sign their efficiency standards before the government mandate that take effect, therefore basically also they are fulfilling their obligation to the societies, to the corporate governments, and also getting some profit there. These are some of the reasons that we find it that basically a lot of people are going into the carbon credits, going to the sustainability we talk about also later on. Also that's when they want to reduce that cost. If you look there, according to Global Feed Survey, there's more than 1 billion metric tons of compound feed produced every year. That means there's 30,000 feed mills that's in the world, 30,000 feed mills. And also currently there's a desire for us to remove some of that CO2 footprint from these mills there, and that is because if everybody do something, they share, hopefully there will be also some progress made on that sense. Therefore, how can we do that? Of course, energy saving and of course cost to the industrial pollution have become a very important issue here. And of course, we need to identify what are our efficient methods, what are our efficient process, what are our efficient equipment that can help us to make sure that we are trying to have energy savers, plus also having some of that reducing the carbon footprint. I found some of these things, like there's 10 points that I will be focusing it that can help us to minimize some of the carbon footprint as well and save some energy. Number one, depend upon how you select your ingredients and what are the sources of ingredients. Number two, be efficient feed formulation. You'll be surprised to know that sometimes we don't pay attention to the feed formulation, but we can, if you pay attention, you can have a lot of energy saving there as well. And then of course efficient method of processing. That's what we're going to hear today all day. Equipment wise, that which equipments are most of that pet food or aquafeed industry manufacturers, equipment manufacturers are trying to make it more and more efficient equipment that reducing the energy there as well. And also waste management, and of course the byproduct utilization. Then we have renewable energy integrations, energy management systems, transportation, logistic wise, research and development. And these are some of that things that we can also do there, like transportation wise, where you bring your raw materials, how far that is, and then also some R&D, and then of course some of the certification and standards practices that can help us to also achieve some of our goal. If let's go by one. Number one is that selecting the raw materials. First of all, you understand the raw materials, and also you know that you build your relationship and also request some sample and find out how they are processing it. Is anybody here making aquafeed have ever visited a company who make the ingredients? Do you know how they process? What are their energy they're using it, how they're processing it? I highly recommend you to go and visit them and see how they're producing their ingredients. Sometimes we don't pay attention because they are maybe using a lot of energy, they are causing your carbon footprint. Therefore, basically, you have to monitor quality, understand your ingredients, visit your supplier, request sample, And then of course you understand that one. Here's an example that I gave that one just to give you idea. The production of the raw materials for Aquafeed was the largest contributor of the carbon footprint extruded for the extruded pet food, extruded feed. And if you use US soybeans and both in the grass, carp and feed, you can reduce by only 15% your also carbon footprint already as compared to Brazilian soybean, and therefore you can see here carbon footprint. So just by changing your recipe, changing your one of the ingredients from that, if you're buying a Brazilian soybean to buy the US soybeans, we talk about also advantage of soybean and other talk, but again here just to give an example, just by changing the source of the raw materials, you can reduce your carbon footprint already, because there's a lot of carbon footprint when you go to Brazil and Argentina as compared to US. Therefore basically you want to make sure that you are rightly using correct ingredients. Also you can use ingredients which can have a low carbon footprint, they are sustainable. That will be, we can see here there's algae coming up, insects protein coming up, microbial proteins coming up. They often produce at a low carbon footprint, and therefore they can also, as compared to traditionally fish meal. Once again, I'm not here to talk about against any of the ingredients, but I'm just giving you some of that fact that if you're using a fish meal, there may be a lot of footprint as compared if you start using insect protein or maybe locally grown or algae, or maybe use some of the other proteins, that will be much easier, and it will be also reducing your carbon footprint. Also local sourcing, depending upon where you bring your raw materials, how far it goes there. Therefore basically if you have something which you are locally grown there, that you can minimize the logistic wise, minimize the carbon footprint on there as well. Therefore you can always look into a first who is producing locally, so you can buy it rather than going all the way. Otherwise it's going to cost you a lot of money there. When you go from one place all the way to there, that transportation is also costs a lot of there. Use of the recycled materials. Also you can incorporate some of that. If you have integrated operation, you have fish byproduct, you can have a fish feed pellet which is not up to the task. You can have some of the ingredients, some of the byproduct coming up from the ingredients. Therefore you can basically recycle your ingredients and then use that as well, and that can also reduce your energy cost. Therefore there is an always opportunity to use some of that, our byproduct we talk about a little later also more. And sometimes we do a lot of extraction and processing of the ingredients, and if you can use that byproduct as well, find in your formulation, that it also helps there as well. Other one is that if you can work with the nutritionists, which I have not, but you can work with there to see that efficient feed formulation. You can create that one and then get much better result. You need to develop something, feed formulation, that meet the exact nutrition requirements of aquaculture species, so you can reduce the waste and improving the feed conversion ratio. Therefore that's called precision nutrition. You can talk with the nutritionist and make sure that you're using the right nutrition. You don't need to use any other extra ingredients, because you don't want that to be part of your extra cost there for the carbon footprint and all that. Also there are some, we call it digestibility enhancer. Therefore some of the enzyme that's available, additives are available that can be used in some of that. They can help you digest the feed, leading to better nutrients and absorption, less waste production as well. Therefore basically you can use some of these, also some of the enzymes, some of the additives which can help you to basically better digest and give you much better result for that. Eco-friendly additives. Also you can use some of that environmentally friendly additives that can also lower the environmental impact, the final product. Therefore there's a lot of other available that you can look into the industry, which is eco-friendly additives that can digest your food, adjust the ingredients much better for the fish and also for the pet food. Now let's talk about processing equipment, also the efficiency, understanding the ingredients of course, and also the recipe in extrusion process. Therefore as a nutrition, we pay attention to target species. In the processing, we also need to pay attention to how do you process them, what kind of ingredients you use them. Therefore uniform grinding, mixing, and low carbon give you low carbon footprint. And if you are having some kind of oil grinders, you're using that one. And of course we're going to hear the next presentation about grinding. If you have an oil grinder making a lot of energy and you are wasting all that because you're not paying attention. Therefore basically you need to get something which is much better, grinders and the mixer, and understand the recipe, what you need for that. If you are going to make it, of course we're going to hear about also ultra fine, a shrimp feed, of course you need to grind very, very fine, you need to go to pulverizing. But if you want to grind it just for a regular one, there are different options available. Proper preparations prior to extrusion will likely process with the greatest stability. If you don't grind properly, your machine is going to stuck in the middle of the extrusion, and then you're going to shut down, and then you waste all your energy and efficiency, and then go back again and start again. Therefore, basically make sure you prepare your raw material properly, you grind properly, however you want to use it, and that will basically resulting the superior efficiency, higher throughputs, yielding, improved producting, eliminating losses, and know your ingredients because they are your best friend. If you don't understand your ingredients, you will be spending a lot of time and energy and all that efforts to go to make some of the product. So what are the equipments that we use for making a pet food and aquatic feed? They are typically, we have typically, of course, number one is, as I mentioned, they are preparing the raw materials and grinding. And we do have a different kind of mixer and grinder which is available. Some of them very, very energy efficient. Some of them take a lot of energy. You just need to look at that one yourself to see which one is the high efficiency equipment that can lower your energy requirement, but is giving the same particle size and homogeneity. You don't want to, as I mentioned there, to go extra fine grind if you don't need it, and also you don't want to do it, coarse grinding, because then you will be stuck in your machine and doing all these things. Therefore, I was able to find one of the YouTube video there that talk about very efficient mixing and grinding. If you want to look into that as well, you can see how that works. Also, there is also we call a circular grinding to save energy and the nutrients. In this case, basically you will have it, some kind of grinders, they will grind it, and then of course you have circular grinder, means all the over material will come back again, circularly rotate that one, so you don't lose any of these things, and you can use that as well in your processing there for that. Same part of like the hammer mills, another one that, but you can basically circulate that all the time so you don't waste any of time. Then my favorite topic of extrusion, then we have to use energy efficient equipments, extruders, that can give you better quality pet food and aquatic feed, but at the same time reducing the energy. And if you look in the modern extruders, you will see that most of the equipment manufacturers here, we won't talk about a lot of different people here today, they all have their efforts, their energy spending on how to make it more energy efficient, which can do that. Therefore, most of the equipment you see today, they are very, very energy efficient. They're trying to do as compared to what you see 20 years ago, 10 years ago, equipment there. Therefore, basically, now we have very, very efficient equipments. Choose equipment which has been developed on the science and the research. That's very focused there. And of course, the packing superiors, technology, advanced process tool for ingredient flexibility, because you can change your ingredients once in a while. Therefore, you want to make sure your equipment are flexible so that it can handle all that, not spending extra energy on it. Therefore, you can basically look into that different manufacturer to see which one is more efficient equipment, which will give you much better result. In aquatic feed, when you make it a pet food, the very first thing comes up is the preconditioning system. The preconditioner usually take almost 50% of your energy. You're making aquatic feed, your 50% energy will go into that preconditioner to make it either pet food or aquatic feed. If you don't have a efficient preconditioner, you're just wasting the money. I just visited last week in Tunis. I was there, and they are using a preconditioner for the pet food where they're only getting temperature to 50 degrees C. I asked them why 50 degrees C, because usually you can get to 85 to 95. They said that's the way we got only, and they're only getting 50 degrees there, because we can almost do it most of the half of a cooking gelatinization in the preconditioner if you have properly designed preconditioner with proper steam injection and all that. Therefore, there are basically different quantity of preconditioner available that can give you much better mixing intensity and all that, precise dial-on formula, so you don't waste any energy, you get exactly what you're looking for. Therefore, look into that different kind of preconditioner which is available in the market. You can get that one as well. And if you can also see that in the previous time we have preconditioner where we're wasting a lot of energy here, the steam goes there, but now we have here, this is the vent which can be connected to the heat exchangers, and then of course we can condense the excessive steam there as well. Therefore, this is a new technology. You can use it where you can use that and then so recirculate your steam there, and also it help you to include your inspection and cleaning port on the top of the unit. But basically, this is just a heat exchanger that all your steam going outside, you can recirculate and use as a heat exchanger there. Therefore, you have to also determine your energy. I'm going to use more mechanical energy, or I'm going to use more my thermal energy, because both have different carbon footprint. And if you look over there, Aquafeed manufacturer basically characterized by requirement mechanical energy for milling, mixing, preconditioning, extrusion and all that. Mechanical energy and thermal energy is used for preconditioning in the extrusion of Aquafeed. And then of course, in order to determine your energy consumption, there are several known parameters. You can calculate that one. Again, if you have engineers in your company, they can calculate which one is more costing me, mechanical energy or thermal energy. Usually in aquaculture industry, of course, these are the specific mechanical energy we use it, specific thermal energy both we use it in order to determine energy consumption. You can calculate which one is more suitable for me in Aquafeed. And most of the times what we do here is that specific mechanical energy that represents the energy transfer from the main drive motor to the consumption of the process measured by mass material. And of course, it's also directly give you how much electric unit electric energy you are using it. Therefore, you need to know that which one is my good, less expensive source or energy savers, especially if you want to use specific mechanical energy, using mechanical energy, or you going to use it thermal energy. In and this is basically thermal energy, where we do most of the cooking done with maybe the injection of the steam, sources their material, and that also it depends upon how much steam you are adding there as well to when you make that fish feed, aquatic feed. In aqua feed mostly, typically fish feed has a very large amount of your high fibers and of course some kind of low quality starches. The ability to increase thermal energy help you to give you much better result and hydrate and heat that. Therefore, if you're going to have it, you want to cook your feed formulation which has little lower quality protein, maybe have a little high fibers, I would recommend you to look into the thermal energy rather than mechanical energy, because that's going to give you a lot of saving there, because we will do that, and the steam will do a much better job than do your mechanical energy there if you do a friction only. Mechanical energy mostly come by friction, which is produced by the electric motor running the RPM and all that, and that will be more expensive as compared to do it when you do it with your the steam. And then a lot of time we have been asked them, what should we do that if we have already existing equipment? How can we improve that one? Because we already have that machine. How do I do that? No, because we have that. Therefore, if you look over almost old timers, very simple barrel. They will not have any steam injection in the barrel. Traditionally, you can only go to 3% of the dry feed rate, and also steam is very small amount. You don't have the port, you don't have the options to that old system there. And therefore, the new system, you can see they have all have a port there for the steam injection, advanced extruding system, and then of course these are designing to give more and more thermal energy than the mechanical energy. And of course, advanced system can handle up to 8% steam rather than only 2 or 3%, which is the old system there. Therefore, you can have it with that 7 bar pressure. Old system only 2 bar pressure, but new one you can have a 7 bar pressure steam. You can inject that one as compared to 2 bar only on the new system here. And I was visiting therefore one of the facility, I'm going to show you some here, also a picture there. Therefore, the question is that how can we reduce energy cost and carbon footprint in the existing aquaculture facility if you already have that one. I'm giving you example, the new systems, and people say, okay, you are talking about new system, Dr. Riyaz, but we already have a system. How can we reduce the energy? And there are some tips for that one. You need to go back and see from your your raw materials to conditioning to extrusions to the dye to the drying to the oil extrusion and the product. You have to look on every single step and basically go back and audit every single thing in the existing facility. Where is my cost most of the energy? Where I'm doing a lot of high temperature extra steam, of how I'm controlling my energy. Therefore, it's not that easy. Therefore, in the extrusion process for making aquatic feed and pet food, you need to basically input your parameters, check every single thing, check your formulations, and go one by one on every single steps that you can see here, what's going on there, and also response there, properties there, to see where is my energy I've been wasted, and how can I control that one as well there. And of course, you need to make sure you're properly controlling the temperature, and that's one of the most common place I've seen people are wasting energy. They don't control the temperature. They're either cooking too high or they're not cooking very well, and they don't know that. If you know that here is that we have a typical extruder, we inject the water in the steam and we convey that one in this way, but we want to make sure that we have fine tuning for the temperature setting so we can maintain our temperature all the time, minimize our energy level. I was in one of the country, not mention the name, and they were making some of the product, and this is the way they are controlling their energy temperature. Therefore, you can see the water hoses there. And then when I asked them, and they said, okay, this is what we're doing it. They are cooking the product here, coming from there in the extruder, existing one. The way they're controlling the heat is that they have a hot, cold water running on that, so they can control there, and then they're making the product. This is the way they are doing it right now. Traditionally, there are some of the countries that controlling putting the water on it. That's all the waste of energy, waste of your, resources and everything like that. That's not the proper way to do it, where you cooking and then just control the temperature, you're putting the hot water onto it and then using that one here. That is not practical way to do that one. You want to make sure that you have all the gadgets there to make sure your RPM, your energy, your feed rate, you are measuring all that there, extruder speed, on that, monitoring it. Even your old existing extruders, you can always replace that one to make sure you are properly temperature-wise. Always you going it, or your RPM and all that. Most of the time when you go and visit them, they say, we don't know what RPM we're running it. And I ask them, you're driving a motorcycle, a car, and you don't know what speed you are going there, therefore how do you know the efficiency of the car? Because they say, we don't have a speedometer, we don't know the RPM, we don't know what RPM we're running there. They're just running it, and they have no reading to read it. So 300 RPM, 400 RPM, 600 RPM, they have no idea what RPM they're running. That's other issues there. Also, I have seen some of the installations that where you can also insulate the barrels. Some people do that one. That also do some kind of saving for the energy. Some of the people using the heating band there, that they also heat the barrel so that you can save some of the energy. In this case, they use some of the energy efficient bands to ensure the proper insulation as well. They can do that. And then also they have advanced monitoring system, control system. Therefore, everywhere you go, you can see exactly my temperature, my pressure, all the things are going on every single zone, every single your extruder parts. You can exactly see what temperature I'm running, what is my pressure here. I'm not wasting any extra energy. You don't need to do that. Therefore, implement advanced process monitoring control system to ensure that you have optimum performance and early detection of the insufficient or the fault. Again, you can see here, that is that screen monitors that you can see here. That is my screw speed there, what is my RPM there, and then of course you can see on every single, actually on the part of the extruders, what is going on inside the machine, how much RPM, what's energy, what's the water, what's the steam we're adding on every single system there. Also, optimized processing condition. That means also material handling. Sometimes you go, you can see that basically they're having a warehouse which is very, very far, and every hours they have to bring a lot of materials there. Therefore, maybe you can reorganize some of these material handling system as well, so you can lower your cost for the energy needed. If you have a very, very old motors, I think it's very common. There's a lot of energy efficient motors are available, drives are moldable. Therefore, in the old extrusion system, you may have one thing which is a motor which is very old one. You can upgrade the energy efficient motor to variable VFD drives to reduce some of the energy cost as well. Also, some of the options available, there's screws there, that's most of the time are worn out very quickly, and you can also do some kind of, there is a coating there that's available. You can coat some of that parts here, so you can reduce some of the energy and some of that all the time making wear and tear to your extruder. Also, preheating and cooling system. Sometimes we can also have a coating, like a preheating system there, a cooling system, so we can do it. We can inject some of the water or heating oil and all the things like that, so we can basically our heat and cool when we need it, so we don't waste any of the energy there as well. Drying technology. After that, you have dry it, and of course there are very energy efficient dryers available that can also heat from exhaust gases get it. Also, I have seen some of the solar drying system available now. Renewable energy power drying system available as well, and they are coming up as well, so you can reduce your energy cost there as well. Also, other thing is which costs you most of that headache and energy is that people start using making their own parts and locally made there. Always recommended that you should buy that originally equipment manufacturers parts there, because that will save you a lot of energy when you try to use other parts that just add up extra energy into it, and you will not be making preventive maintenance, so that you don't cost your time down and also your waste of your energy. Therefore, look into the whole equipment systems, not only just the extruder system, but you want to see there that from your raw materials, from delivery there, coming up there, the grinding system we talk about it, your mixing system coming from the extruders, that coming from the dryers, coating all the way down. You want to process that, make sure that you check every single steps and make sure every single is working properly. Software, you can do a fine tuning. A lot of people using software there too. They can control their software wise. You can formulate, maintenance, all these things. We give you a lot of information with that. And the condition of the process must be stable. So it also help you with if you have a proper software as well. You can fine tune with that one. For example, this is based upon the science and arts. People have a lot of online equipments available now where you can do the bulk density, you can do the fat coating, you can do the moisture, protein, all these things are available. Therefore, it will help you to do that. If you can start also doing some of that automation there. And of course, again, I mentioned that the whole process, you can train the whole, your team there, and they can all get benefit. And of course, improvements are immediately noticed and measured if you use some of the software properly designed. And also make sure you have your specification set up first, because you want to make a floating feed which is certain amount of fat and protein, and then it has to be different size, and then you realize that's not proper size, it's not floating, and then you waste all that product, and that's your waste of energy and all that. Therefore, what we recommend here is make sure you talk about your specification first. You want to make it floating, you want to make it sinking, what protein, what fat content you want it, and then of course you go there and you use that one. With that, after you set up your specification. Therefore, the final product specification comes the first one to establish that one. Therefore, if you decide you want to make a pet food, some certain amount of pet food with certain amount of protein, the aquatic feed, set up that first before then after that you don't realize that you wasted all your energy and time. Provide training to your employees, trainers to your say operators, so that they can understand as well troubleshooting and all these things. Then briefly we'll talk about some of the waste management, byproducts utilization. We have a lot of system available to recycle your waste. If you have something off spec comes up, your startup material, your shutdown material, you can recirculate that. Systems are available where you can bring your all that recycled materials into it and make a slurry, pump it back to the extruder, preconditioner, and use that one. So if it's a wet, you can add more water, make a slurry. If it's a dry, you can grind it, and then you can add it into your recipe as well. Recycled waste also, you can have some of the waste, it can be used preheating that incoming the air in the dryers. You can have the incoming air comes in there using the heat exchange and all that. You can also use that, and then of course recycle that as well. Organic waste can be processed into bio. If you have system there, you have some of the organic waste, use that as well there. Circular economy, as mentioned there, adopt circular economy. Therefore, you have some of the processing of the food ingredients, or you have some other ingredients there, you're processing them. Also, byproduct comes from there. A lot of byproducts that you can use it for agriculture residue, using the feed ingredients, of course, reducing the overall waste and energy uses. Again, here's the byproducts and waste coming from there. Byproduct from the waste processing industry, food processing industry, dairy industry, meat industry, all that sugar, that can all be used in your formulation. If you have access to these byproducts, that will reduce your also energy, a lot of them there. And of course, we talk about waste recycle, we talk about that. Therefore, utilization of the off-spec product. If they're off-spec, you can always use them. Of course, you don't want to go any water go into the drainage. And of course, you can use all that, your product there. If you can see here, energy consumption in Aquafeed and the pet food, around 45% come from drying and thermal energy, and some of them coming from extrusion and thermal energy, rest of that. If you can monitor that, where you are wasting a lot of your energy, you can focus that, okay, where I'm spending most of my energy, and how can I reduce that one, and what part I can reduce as well. With that, thank you very much, and if there's any question, we'll be happy to answer that. I think I took my time there, but if there is any things that we can answer, or maybe I will be here all day if you want to discuss one-on-one. We do have a Texas A&M always do it, as Raju mentioned, short courses, which is 1 week long. If anybody want to know more information, I will just finish the feeds and Aquafeed in January. I know we're going to have our pet food and treats will be in July, and then in between we have other snack food, other courses too, in case anybody interested with that. Thank you very much.
I'm Phil Erickson from Reynolds Engineering. We've been doing a lot of fine grinding for Aquafeed for about 35 years. Mostly in those days for shrimp feeds, typically pellet mills, not so much extrusion for those. Floating feeds were made at that time on various types of extrusion equipment. Today it's probably more extrusion than anything else, just because of the efficiency to cook and whatnot. But this is our contact information, and we can give you any kind of information. This is kind of quick. I would recommend Niam's courses. They get into a lot more detail. We're going to go kind of quick today, so this is just what we're going to get into today is why would we want to spend the kind of energy doing fine grinding versus just using any kind of hammer mill. The number one thing that you grind material on is hammer mills. Okay, and usually you would only use a fine grinder like this for very small larval type feeds, things like that where you have small die openings. The spec keeps changing. Back when I got in it, it was, if we got 80% through a 250 micron, which is about 60 mesh, that was pretty good. Today it's more like 170 micron, which is about 80 mesh. That's kind of, these are for the smaller dies. The dies have gone down in size too. So we're just going to try to talk through some of these things kind of quick. These are the points we're going to try to hit. And basically, what is fine grinding? I call it anything you can't do on a hammer mill. Now, a lot of guys promise they can do all kinds of stuff on hammer mills. They even call their hammer mills pulverizers sometimes. To me, they're not at all. We're not going to talk about wheat today. Aquafeed generally, we use this 80% 250, which is 60 micron, or 60 mesh. That's kind of where we get into the point where we might want to start thinking about a pulverizer, something like that. Depends on what you're after, though, for looks and whatnot. Aquafeed has a lot of issues with it that got into fine grinding before, especially in the pellet mills when all they had was a conditioner to do the cooking. The finer they ground it, the more ability they had in the preconditioner to get it cooked. So we're just going to kind of blow through some of this stuff. And I just point out here, all we're doing here is just showing you that however you want to measure the particle, you can do this with light diffraction, which is kind of really quick. You got to watch out a little bit because it's actually usually by volume. And if you use these kind of, we actually get involved in a jet sieve. This is an air suction type unit that it's basically a screen. And you can get ones that are roller taps. They tend to not work with the high fats. This one works real well with high fats. We used a lot in Aquafeed and Petfoods. But for much quicker analysis, this red line here is laser diffraction. But we just got to make sure that they've got algorithms now in these things that actually try to convert it to a by weight number so it can be compared. When you do that, it still comes off a little different. It's not always the same. Anyhow, to get through that, we're not going to. This is something that we've been doing. We originally did it it was designed to do for pet food. We were trying to get a high protein, which is this green line here, meal out of this. And we were trying to separate it from this high fiber section, get the protein out of the fiber. And then we were trying to pull off a large amount of starch because we'd end up with too much starch. So the starch market goes up and down. This meal you don't get much money for. It's about what you paid for the piece to begin with. But this is where the money is in the protein. It's always about protein, really. So we did this for pet foods. The plant was designed to go into Aquafeed, but in the end of the day, the pet food people gave the people that were doing this, that we supplied the equipment for, they got more money in the pet food business than they could get in the Aquafeed business. So not so much of this goes into Aquafeed. But it's an interesting system of taking a pea, a legume, something that's easy to grow, doesn't require a lot of inputs, puts nitrogen back into the ground. So it's kind of an interesting thing, and there's a lot of alternative crops now that you can do this kind of thing with. So it's kind of we think it's the future. The unfortunate part of this is it requires a little more complicated system. It has to be double air classified. You pull off the starch, and then you grind it once in a pulverizer, and then you have to classify out the starch, you classify out the protein, and it becomes a little more of a process that the operators have to understand. Anyhow, to move on, this is kind of one of our failed things. It's not really a failure. This was an alternative crop, And it had the brand on a wheat product or something at the outer layer. And they found it still contained about 12 or 14% protein. So they wanted us to grind the heck out of it to liberate the protein. It turned out it's not cost effective to do that. It uses too much energy. So it wasn't really a good thing, but what we did notice, okay, this hammer mill product was in a fairly fine grinding hammer mill. You can see the angle repose, which is how some people measure flowability. Sometimes the extrusion people might want to do that. When we got it all ground up, we liberated the fiber, and therefore that test doesn't really work. It's kind of the exception that proves the rule. But it did liberate the protein. Unfortunately, it just cost too much to grind this product. But there were other interesting things we got out of this. It's actually true with a lot of things. As you get finer and finer as you grind it, you're going to get a more uniform color. Now that's probably more important to the pet food industry that you're selling to the consumer. Okay, whereas it's still important to the Aquafeed guy because you're still selling it to the farmer. And he wants a uniform looking pellet. He doesn't want a lot of roughage on the outside of it, at least that he can see. So it was kind of a failed test, but I like to put it in here just because it kind of clearly shows that these things kind of become more uniform in appearance as you grind them finer. These are some of the physical properties we get into. Really the two important ones are the size, the size of this thing. And we're looking at spheres basically, and that's not always true. There's a lot of fiber. So that's one of the reasons we get into this specific surface area issue. But if you're just thinking of it as spherical material, it's the particle size, however you measure that. And we use the volume of the powders. So we get, with the particle size, we're measuring usually the diameter. And with we usually want to know how much volume we're going to have because we want to be able to anticipate the density of the product at the end of the day. And these are just some calculations you do. The other thing involved in this is, and I'll explain why these are important, the surface area is calculated. We do this for another reason. And to get the overall, we use a specific surface, which is just, again, playing with the math. But it gives us a number that kind of, neither one of these things are important in their own. The specific surface sort of combines the volume or the diameter of the particle kind of with the surface area. And here I'll this is kind of what happens in this. As we grind finer, we're going to get a specific surface that's going to go way up. And usually today we're hunting somewhere in here for most of the Aquafeeds, not all of them, the small pellet type Aquafeed. And that's where you'd use this kind of machine. Would be not from this 250 number, but down in here. That's kind of what the new specs are kind of going to. A lot of people want them to go that fine for a lot of reasons. And as we move on from that, some of the reasons we do this, and I think the extrusion people will tell you, about a third of the die size is usually what you're shooting for. Whatever that size is, if you're doing a 0.5 millimeter, which is pretty small, that's why they started going to 170 micron. If you get about 99 point something percent of the material, you're going to have a low percentage of material clogging those dies. And that's important. I think you talked about the waste of energy when you start clogging all the dies and whatnot. And then we get into the radius of the particle. It's just simple math or simple understanding that we do this for a lot of thermal reasons. We always say it's important. It's the distance to the center of the particle. So how fast can we get the heat to the middle of the particle? So that's another reason to have a small diameter of material. The other thing about this that I thought I changed it, but maybe not. For digestibility, proteins, you want to thermally process them. And a lot of that is kind of combined with moisture, getting moisture to penetrate the particle. So the smaller the particle, it's going to be easier to get that moisture into the center if you want to get the most out of your proteins. And then the surface area is the chemical reaction that takes place in digestion, whether it's acids or enzymes. These are all things that you need to do to get the most out of your proteins, at least, So we're trying to grind fine, and to help us in the processing, the thermal processing, the cook, and a lot of that is dependent upon how much moisture we can get to the middle. We don't want to have the particle only partly moisturized. We want to get as much as we can. And the same thing is we want to maximize our surface area. 2 reasons that you might want to grind fine. So we improve digestibility if we do this through both of these processes. If we process, the advantage of processing and getting it to a third of the die size is just a mechanical thing, so we don't clog those dies. I'm having a hard time keeping this microphone from my mouth. And then there's another reason. This is something else, doesn't need to be mentioned too much, but when we go to a fifth of the size, if you're doing crumbling, if you're going to do that, we want to get it a little bit finer, and then you're going to crumble it down to whatever size you want. And it's got a lot to do with the pellet breaking apart properly. So this is another thing that you would kind of set up your size for. The other thing is for marketing superior appearance and uniformity. And then the reduction of fines, these are kind of related to that pelleting issue, but sometimes they're called fines. When they're in the bag, you made a bunch of pellets, the guy opens the thing, dumps them out, and there's a bunch of small powder at the bottom of the bag. We don't call these fines because they're actually coarse to us. It's the weakness in the pellet has to do with the larger pieces, not the small pieces. But the industry is kind of calling them fines. This is also true when you pellet, you're going to get fines. You're going to get a waste stream. And if you can do that more uniform with smaller, finer ground material, you'll have less weaknesses in the pellet, and you'll generate less of these so-called fines. But when you're talking to us, they're really overs. They're large materials that cause a weakness or a fracture point. So anyhow, that's kind of why we do it. And this is just a quick thing. We do a lot of shrimp feed. We did a lot of tilapia feed, eel feed, for a lot of reasons, larval feeds. Pet treats, pet foods. We don't typically do a lot of pet foods with pulverizers. We do a lot of things that go into pet foods. So, and also, if you're doing a really premium pet food that you might want to get a real nice finish on, if that's a market for that pet food, there's all kinds of marketing for pet foods. And treats, you never know what they want them to look like, so sometimes they put additives that they want really fine to give it a color of some sort, or it's not really for the pet, but it's for the consumer. And then we're just going to get real quickly here, this is one of the reasons we got into this business a long time ago. They had black tigers, which aren't as common today. Most people do. The Vitamine is probably the #1 market, but they're still a high premium type shrimp. And the idea was to get the most out of the protein, get the shrimp into the pond, get it out of the pond. Back in those days, they had a lot of problems with disease and whatnot. So even getting it out a week or so earlier was important. So they did a lot of processing to make sure they're getting the most out of their proteins. And, that's kind of how I got into it. But we do a lot of other things nowadays. These are the real 2-type pulverizers, and one might be, this is one like we supply. We call it a horizontal mill, and this is a vertical mill that was originally built by, it's owned by House of Cow, not the original design, but Micron Powder Systems. But in this one today, they've done a lot of mods to this, where they've extended the chamber up, and this is like I say, a micron powder systems ACM. You can put the material in this way onto the plate, or you can suck the material up, the air comes up through the bottom, and then they've extended the chamber up. This is a classifying wheel driven by a separate motor. This has got a motor down here, the main motor that spins the grinding plate. And the faster you spin the classifying wheel, it rejects the material and kicks it back to the plate. Both of these kind of use the same principle of kind of momentum and buoyancy. Once it becomes buoyant, it's the same Stokes' law. Air is just 1,000 times less dense than liquid, but it's the same calculations. And all we're trying to do in both these things is the material comes in, the large material will maintain its momentum. It will stay in the grinding chamber, same here. And then once it gets light enough and small enough, and its surface density to mass ratio changes, the airstream takes over and will remove the fine material out. So it's just like an air classifier. We're both trying to, no matter what type of machine you use, we're trying to classify it and separate it without doing a separate classification. Because these things get sticky and they're usually higher fats, and once you put it in a bin and let it sit for a while, it can stick together, and then you're back re-separating it. So the idea is to do it kind of all in one step. So these are the two types. You can get this unit in a lot of countries. You can get this unit in a lot of countries. And they're actually very similar. You just got to watch out. The energy efficiency is really about the same. We're doing the same work. We're breaking particles. It's hard to get around that. We're hitting them with hammers, and it's really hard to make it much more efficient than that. This, though, does appear to have a less main horsepower that would drive this shaft, but then you got to add in the classifying wheel. This one is just one motor, and they're all controlled by VFDs usually, so you can adjust them. And there's a lot of claims out there that the hammer mill guys have that they say they can do the same thing. I haven't actually seen them be able to do that, but improve it. Now, this is another thing we're doing here. Ours, in most of them, they don't have screens, so they're not like a hammer mill at all. Hammer mill's trying to take that material, let it go through the screen, and it's going to try to leave the large particles in there until they get ground. Typically, these machines will handle a lot higher fats. We're both using a lot more energy than the hammer mill. It's just, we don't have screens. We're trying to bounce materials off of these grinding materials, which are a type of carbide, into a nickel chromium type liner. We try to pick those materials that are most cost effective, and we're trying to do that for every market. And markets where they're using cheaper materials sometimes might be harder to grind. We don't want to wear it out, but we want it to be cost effective. So we can change the formulation or use different materials so we can get what's going to be best for you in that market with that formulation. And again, we're just kind of skipping through this. In the old days in Thailand here, you would see this kind of a system. It's not really sold anymore. This is all the only, I'm trying to point out here one difference. They're not like hammer mills in the sense that you can put a bin vent. The earlier presentation showed hammer mill with a bin vent. That's a pretty economical way to go. Can't do that with a pulverizer. But this is the older system you might see in an older plant around here. They've been sold here. The new way to do it is more like this. We haven't done it the old way for 25 years, but you see a lot of them out there still. This system is just a simple pulverizer. It's removing the material. About 99% of it comes down through the cyclone. This gets put outside, so there's the fan. And then today we actually, for a lot of reasons, we're removing or putting the sifter in. Now we'll talk about the sifter in a little bit, but we're really just trying to remove any foreign materials, plastics, any kind of metal. you know, anything that, and also we're just trying to maybe scrape a little bit of some of the grains have this material that's very hard to grind, but you find it's very hard, it's not digestible, at least in most of these aquaculture species. I always say you should just send it off and to the birds that have a gizzard. So another design feature that we're getting into today, typically you'd have to have explosion panels on this, so if we put it outside, we're better off. If we put it inside, it's got to be next to a wall, and it's got to have a direct vent to the outside. We can vent to atmosphere. It's just cheaper, and you see it on a lot of plants where the air collectors are now on the outside. And the other advantage to this system is in 2013, we were told that there'd be a regulation that you're going to be having to isolate each one of these. But if we vent to atmosphere, we don't have to have an isolation valve. And the concept is if a fire was to start here, and I don't see a lot of them at Petfoods or Aquafeed, matter of fact, none that I know of. But anyhow, in the future, we may have to put isolation valves so that if there was a fire here, it doesn't jump to here, it doesn't jump to there, at least inside the building. So it's kind of a regulation issue. And what we're doing, a lot of companies are doing, is they put in this type of system, knowing that someday they may have to put an isolation valve in there. If the I don't think anybody's worried about any regulations in the U.S. for the next 4 or 5 years. But anyhow, that's kind of the way we try to design things today. And also, this allows for quicker cleanup. If you do get a foreign product in here, especially if the guys have been working on the system or the pipes, and there's a lot of welding slag or tools that drop in here, you might not want those to go into your extruder. So you've got to clean it all out, and this is much easier to clean. All the filters are out here. You don't have to change them. You just go in here and blow it all out, get it cleaned out, and you can be back up and running. So there's some real advantages, and there's actually cost advantages to doing this type of system that's a little bit less expensive. And I think this is just a 3D system that we have here. 3D drawing, same system. Not so common to send that material back all the time. You've got to analyze it. If it's a real clean material, it's already been cleaned, then yes, if you had an oversized product coming off the screen, you could send it right back into the pulverizer. Today, that's not done very much. So you're going to load it. I'm showing bulk bags here, but usually it goes right to a hopper that's going to go into an extruder. Would be more common. And again, there would be a separation wall here, keeping this stuff inside the plant and this stuff outside. So if there is, usually when you get fires, the number one spot is in the filter. And if you can keep that outside, you're not going to burn your plant down, is kind of the concept. Anyhow, this is what typical pulverizer that we sell. Direct drives are becoming very common. They work really well with inverters. These plants can be quite messy. It's nice to have a coupling instead of a belt. Sometimes the belts get all full of fat and oil and they start to slip, and then you got to do all kinds of work on them. Some maintenance guys can handle it. How am I doing on time? Okay. This is where we kind of seem to be going, is screening, cleaning, just trying to get rid of materials, anything that's in there that's oversized, anything that might clog the dies. I think, I don't know if I mentioned it earlier, one of the things you get out of fine grinding is you're going to have less friction. So you're not going to be using your extruder to grind particles. You're going to reduce the wear. Unfortunately, that also reduces the mechanical energy. So and then because it's finer, you can get it into the preconditioner, get it moist, get it into the extruder. You're not going to use as many wear parts in the extruder. Something to think about. Any parts for the extruders are way more expensive than grinding parts, believe me. So anyhow, we're trying to get any kind of packaging material, extraneous objects. Today the big thing is plastics in the fish meal and whatnot. Not trying to clog any dies, we're trying to keep everything operating nice and smoothly. If we have surging and stuff, we want that to be in the grinder, not into the extrusion equipment. Typically, we use a type of screener that I think I showed you before. I guess we could go back and take a quick look at it. We use this type of screener. We think it works best for these applications, where you're just trying to scalp a few % off. You're not trying to corrupt the diet. Whereas some people will use various screening systems, and I've been testing them, they may take off 60%, but unfortunately, if you remove 50% in the screener, you're not going to have the same diet. It's going to be a different material. You might get some of the coarse material out, and you're wasting valuable product. And you can regrind that a little bit and keep doing it, and it's a lot of work. I don't think it's very efficient. But in our system, we're just trying to scrape maybe a couple % out, a little bit of plastic and some other stuff, a little bit of hard to grind material, which I believe is related to digestion. If it's really hard to grind, it's going to be hard to digest for these species. Although chickens and stuff have gizzards, so they can grind it up. That's why I say take that material and give it to the chickens. But anyhow, these are one of the things that are going for us. It's all about reduced starch, at least with some of the plant materials. Reduced need for starch because our particles are smaller, and that starch is going to be more effective at sticking all the little proteins together. At least that's what people explained to me. Grubs, algae, this kind of things. These are the things that we're looking at. We don't know where it's going. Everybody talks about algae all the time, but as I understand it, the oil is way too valuable to be used a lot of times. The grubs are definitely being used. The soldier fly type, larvae and all that. It's definitely expanding. But plant-based proteins, everything's about protein. And everything's about reduction of fish meal. So if you can figure out a good amino acid profile and whatnot in your plant materials mixture, that's kind of where everything seems to be going nowadays. And those you do need to grind pretty fine. Anyhow, that's pretty much what we were going to cover here today. And this is our main plant. We have a couple of places.
We have 2 minutes. Any questions? No. Thank you very much.
All right.
It's okay. Don't close.
Good morning. Thanks a lot for the introduction and for giving me the opportunity to be standing in front of you today. So if I'm here to talk about the extruded fish feed, and we'll see together how using the twin screw extrusion technology is a good lever to face the challenging of fish feed extrusion. So I will start my presentation by introducing Clextrol. So I will give you some inputs about who we are and what we are doing. Then we will study together the global context of fish feed production, what's happening, what are the manufacturing challenges. Then I will introduce the technology, meaning the twin screw extrusion, what is an extruder, how is it working. And then I will give you some inputs about what Clextrol can offer you in order to produce like a qualitative fish feed. So I will just quickly introduce myself. So my name is Wizon. I'm Clextrol APAC process engineer. I'm based in Singapore. So Clextrol, who are we? So our main business is to manufacture and to sell twin screw extruder all over the world. But not only, we also manufacture other equipment such as dryers, coaters, cutting devices. The aim is to be able to provide to our customers turnkey process line and complete solution for different application productions. We are also process experts. So basically that's my job. I'm a process engineer. That means that my job is to support our customers not only for the commissioning of the line, but also for R&D project, for example. If you want to try new raw materials, if you want to develop new texture, new shapes, I will be the one supporting you. We also provide on-site training, remote assistance, and all the support regarding the wear monitoring and the spare parts. So Klextrol is a French company, so it was created in 1956. We are based in Firminy, so for those of you who know France, Firminy is not too far away from Lyon. It employs more than 300 people in many different countries. You can see here on the map that our footprint is almost in every continent. And if we zoom on the APAC region, our main office is in Ho Chi Minh City in Vietnam, but we also have people in India, in Australia, and I'm based in Singapore. 80% of our activity is made outside of France, so we work with 80% of exports, and our equipment are nowadays present in more than 100 countries. Also, something that is really important for us, through years, we develop a wide R&D network with many of our partners. The aim is to be able to provide to our customers or to new prospects the R&D knowledge and to give them the opportunity to try our machine, to benefit from our process expertise all over the world. So we have many, I will talk about that a little bit later, we have many R&D partners also in APAC region. On this slide you can see here one of our extruders, so this one is called the EV32. And here at the bottom you can see also a complete Klextrol line, so this one is for snacks processing. So you can see first the preparation and the mixing of the raw materials, the extrusion unit, the dryer, and the coating device. So this example is for snacks, but we do not only make snacks or pet food. We have many applications. So the first one will be the plant-based proteins. So we have two different ways of producing the plant-based proteins. The first one will be the dry process that we call TVP, texturized vegetable proteins. And then we have the wet process that we call HME, high moisture extrusion. HME is mainly to replicate meat analogs. If you want to mimic a chicken breast, you can definitely do that with HME. We are also working on ingredients and flavors. Ingredients can be modified starch, emulsifiers for example. It can also be instant pudding, mainly for kids consumption. We also provide the flavors. So flavors, the main application will be the flavor encapsulation. Okay, so that's the small balls that you can find if you open a tea bag, for example. You can find this application that we call the flavor encapsulation. Of course, if I'm talking today, we do also pet food and fish feed, which is quite an interesting business for us. So I will develop that in the next slide. And then also a really important one will be the snack and breakfast cereals with many different type of products, many different type of raw materials, many different texture, many different shapes. If we focus on fish feed production, so at Klextrol we're able to go from 20 with our smallest extruder, so this one is an EV25, and we are able to go up for the biggest extruder to 34 tons per hour. If we have a look at the process, we can see that the extrusion is at the heart. It's a really important step of the fish feed production. So everything before will be the preparation and the preconditioning of the raw materials. Then you have the extrusion process, and then after we will post-process the pellets by drying them, coating them, cooling them, packing them, and then after we'll be ready to sell the pellets or to directly use them. So now that you know a little bit more about Klextrol, we'll focus on what's the context, what is the situation about the fish feed production, and also we have to question ourselves, what will make my pellets a good pellet? What am I expecting from my pellet? So in the second step, we'll be able to choose the right technology to make a qualitative pellet. So if we have a look at the figures of the global aquaculture production, you can see on the graph and on the table that since the 50s, the global aquaculture production has increased by 8 times. So that's quite a lot. And on the table here, you can see, so that's the latest figures that I found. So between 2021 and 2022, the global growth of aquaculture production is around 3%. This means that there is needs to feed all those species, all those fishes. So that means that you still have big opportunities on the market for fish feed producers. So the demand is becoming higher, but the way that we will produce the fish feed is also changing. As in every application, also for food consumption, for human consumption, for fish feed, we can see some trends, and here we will focus on the change of the formulation and especially the reduction of the fish meal in the fish diets. So we can see here that this use of the fish meal is decreasing a lot for many different reasons. The first one will be the cost efficiency, because the cost of the fish meal is fluctuating a lot. That makes even more harder to master your production cost. For sustainability, to limit the pressure on the maritime stocks, to improve the formulation. So basically what's happening is that we will reduce the fish meal and we will replace them by plant-based raw materials, so mainly proteins. It can be soy concentrates, pea isolates, and so on and so on, to ensure that your feed and your nutrients will be well absorbed and well digested by the species that you will feed. And last one will be to comply with the certification and the labels for the country that you will sell your product to, and also where you are producing your pellets. Okay, so now that we know a little bit more about the context, what will make my product a qualitative product? So we can identify three main sections. The first one, and I think one of the most important, will be that my pellet has to be suitable to the species that I want to feed. The size, the density, so the density I will focus on that right after because it's really important for fish feed consumption. The shape. For example, if you want to feed a shrimp with a pellet big like that, it cannot work. And that's the same for all the species. You have to identify what will be the size, the texture, and the shape like necessary to be made to feed in an efficient way my species. And last will be about the nutrition and the digestibility. I have to match, if I want my fish to grow, depending the age of my fish, I will have to match his needs, and also to be able to ensure that the nutrients will be effectively used by the animal. I will have to ensure an optimum digestibility. The second one would be, it has to be suitable to the environment. So it has to be water stable. It has to show also a great mechanical resistance. And also, this is mainly for the manufacturing question. The storage has to be stable. So my pellet has to be stable during the storage phase. The last one, which is also really important, would be the cost and the manufacturing constraints. So select the good raw materials that are available, and also to master the cost of my raw materials. We talk about the fish meal. We reduce the fish meal to master in a better way our cost. It's the same for all the raw materials that I will choose. To match the regulation and the certification, and of course if I want to sell my final product, I will have to match my customers' expectations. So now we will focus on the density. So you can see here on this graph on the right that all the species, all the animals are not living at the same depth in the water. That means that if I want to feed a catfish, I will have to make a floating pellet. If I want to feed a cod or a shrimp, I will have to make a sinking pellet. To make my pellets float or sink, I will work on the density, meaning that if I want a floating one, I will reduce my density, and if I want a sinking one, I will increase my density. So the behavior of my pellets depends on the density, but also, you can see here, on the type of water I will put him in. Like in seawater, it will be easier to make a floating product, and in fresh water it will be easier to make a sinking product. Okay? About the size, usually we go from micro. When we say micro, it's around 0.5 millimeter of diameter, to macro, around 3 centimeters diameter for the pellet. So now we'll focus on the technology. So I will introduce a little bit more what is the twin screw extrusion, what is an extruder. So here you have a picture of a global extrusion unit. So the first thing will be the preconditioner. So basically I will have a feeder here, and then my raw material will fall inside my preconditioner. And inside the preconditioner I will inject steam water, and I will mix my raw materials with it to ensure a great digestibility of my final product. Okay? So here I will pre-cook my starch and my proteins. Then, so this is the flow of the raw materials. My feeder, it falls into the preconditioner, and then it will fall here in this part that we call the barrels. Inside the barrels, you will have 2 twin screws that are interpenetrating each other, and then those screws will mix, will shear, will cook my raw materials to make something like a dough, and then they will push this dough to what we call a die assembly that will shape the product, and then thanks to the die space cutter I will be able to cut my product and to regulate the shape and the size of my pellets. So if we have a look at this pattern, so we focus on the barrel step. So if you remember correctly from the last slide, you have your feeder, your preconditioner, and then here the powder is falling into the screws. You can see that the screws is not like the screws are not the same throughout the process. I will focus on the screws right after, but it's really important also to master the screw profile to be able to match what you want to achieve, depending also on the raw material that you are using. So anyway, the raw material will be falling inside the screws. It will be mixed, sheared, and cooked through the screws, and it will be pushed to what we call the die assembly. So the die assembly is made of 3 different parts. So the first one is the central die plate. The aim of this die plate is to converge the flow in only one kernel to be able to distribute in a good way all the flow to the insert holes. The insert and the flexibility that like the insert is offering us is really important, even more for snacks. For snacks it's the same process, like it works the same way. And then if you want to produce curls, rings, balls, if you even want to produce dolphin, elephant, flowers, whatever you want, you will just need to change the type of insert, and you will be able to shape your product the way you want to shape it. So now if we focus on the screws that are inside the barrels, so the screws looks like that. They are interpenetrating, and this interpenetration gives to the process a positive displacement pump. That means that it will push efficiently all the raw materials through the die. We have a great flexibility, as I said earlier, into the screw profile. So in the machine we have 2 shafts like that, and then we'll be able to set our screw profile depending on what we want to achieve and the raw materials that we are using. We have 3 main types of screws. The first one will be the conveying screws, mixing screws, and shearing screws. If we zoom out from the screws and if we have a look at the global extrusion unit, here is a good example of all the process levers that you have to master your process. First one, the preconditioning. In my preconditioner, I will be able to first work on my formula and on my raw materials. My throughput, meaning the flow of the raw materials, but also the flow of water and steam, the way I will mix my raw materials, and also the residence time. It's really important to master the residence time. I will show you right after. We will focus on the preconditioning step, and it's really important in order to ensure a great digestibility of your final product. The thermomechanical cooking is happening at the barrel steps. So we have the operating conditions. Operating condition, I will be able to play with my screw speed. I will be able to play with my water input, my steam input, for example, the temperature profile as well. We have the technology design, the screw profile that I will set is really important. Also, am I going to use a degassing devices or not? And the last one will be the die texturization and the cutting. I show you the insert, so the type of insert I will be using, the size of my insert, the shape of my insert, the number of hole I will put, and so on and so on. So now I will show you some example of the influence of the parameter on the final product. So the first one here is the ratio between the water and the steam injection in the barrels. On this example, we put only water, and on this example, the number 2, we add 75% of steam. You can see that injecting steam in my machine will help me to increase the size of my pellet and to reduce my density. If you remember correctly from what I said before, if I want to produce a floating pellets, I will definitely inject steam in my machine in order to decrease my density. Okay? The screw speed. So this example is about dog food. The process is almost the same and the raw material that we are using is almost the same. So it behaves in the same way in the machine. If I increase my screw speed, again 2 examples. So for each example we used exactly the same raw materials and all the other parameters are the same. We just change this parameter, so here is the screw speed, to be sure that we really study the effect of one parameter. So if I increase my screw speed, I can see that I will increase the size of my pellet and I will decrease my density. Again, if I want to produce flooding, I will increase my screw speed, okay, to reduce the density. The screw profile, we set 2 different screw profiles. The first one has a bigger shearing part, a bigger shearing portion, and you can see that increasing the shearing part in my profile will increase the size of my pellets and will decrease my density. Again, for floating, I will definitely put more shearing elements on my profile, okay? The temperature, if I increase my temperature, again, I will increase my pellet size and I will decrease my density. For floating, I will use a higher temperature. And the last one will be the vacuum degassing effect. So using the vacuum degassing allows to reduce the size of the pellet and to increase the density. So this one is mainly used for sinking, okay? Because I want to increase my density. That means that I will use the vacuum degassing. And you can also see that using the degassing will make my product darker. Okay, so now that you know many things about the situation, the technology, I will introduce what Clixroll can offer you in order to be able to produce qualitative fish feed. So let's focus on the preconditioner. The aim of the preconditioner is to pre-cook my starch and my proteins to ensure a great digestibility of my final product by the species that I'm gonna feed. So what's happening at the preconditioner? So the raw materials is coming here. We have a mixing, so it will mix the raw materials with steam and water. It can also be slurry. And then it will fall into the barrels. Our latest range of preconditioner is called the Evolon Plus preconditioner. So it's flexible and it has a strong design. It has also an hygienic design, because you can see here you can open the preconditioner in order to clean it in a very efficient way. Inside, if we have a look at what's happening inside here, we have counter-rotating twin shafts. So you can see the first one here, the second one here. The aim of those shafts will be to really efficiently mix my raw materials with my steam and my water to have a very efficient pre-cooking of the materials. And the latest innovation, I would say, about this preconditioner will be the use of the advanced filling control screw. So you can see here at the bottom of the preconditioner, so that's here inside. This screw is going in the reverse way compared to the flow of the raw materials. And the aim is to ensure a greater residence time inside my preconditioner. Because I know that the greater will be my residence time, and then the highest will be my final digestibility of my pellets. You can see on this graph that by using this screw at the bottom of the preconditioner, so here on this one I'm not using it, here I'm using it at 60 RPM, I will be able to increase my residence time from 2 minutes to more than 3 minutes. That means that I will be able to increase a lot my residence time, and my filling ratio will go from almost 50 to more than 70. So I will win 20% of filling ratio, which is quite a lot. Also, what's really important, when we are stopping the machine, this will be able to limit the waste, because you always have material staying in the preconditioner when you stop your extruder, and then this screw will be able to go on the reverse way to be able to flush out all the raw materials inside. So we have different range depending on the throughput you are working at. So the smallest will be 75 liters and the biggest more than 3000 liters. And of course, if you increase your free volume, you will need a greater power. So you can see here the different size. You can see there is a human here. The size of this preconditioner is pretty huge. If we focus on the extruder itself, our latest range is also called the Evolon Plus, but that's for extruders. What's new with this one? The first one, it shows and it offers a large operating window, because we have an optimum between the torque and the screw speed. Maybe it does not ring any bells for you, but for me, as I'm working a lot on extrusion, I can tell you that this is like helping me to have a really great flexibility on the machine. I will talk about the heat management right after. The direct scale-up, this is really important also, because at Clextrol, we want to be able to replicate what we are doing at the R&D stage to industrial stage. We know that with the really small machine, we are not able to scale up. And what's the point of making R&D if you cannot scale up to industrial scale? So from our smallest extruder, which is called the EV25, so the diameter of the screw will be 25 millimeter, you will be able to replicate the exact same product at the R&D scale to industrial scale. Okay? The hygienic design. Our machines are fully openable. We have two different types of opening. So the direct one, so you can see that here the barrels is just opening to unhouse the screws. And then here is the two-time opening, two steps opening. So first you will open a first frame, and then your barrel will be able to slide on this frame. The last one will be the volume capacity. If we compare our Evolon range to our Evolon Plus range, the free volume inside the machine has been increased by 40%, meaning that with the same footprint, I will be able to work at like higher throughputs. If we focus on the temperature regulation, so here you can see a barrel, and you can see inside the barrels you have a lot of pipes where it's circulating the cooling water. Around these barrels, I will plug a resistive heater, so you have the resistive heater around the barrels. And when you will put a setup, so you can set a different temperature for each barrel you can see here. The machine, thanks to the advanced thermic control, will be able to calculate if it has to open the water and make the cooling water circulating inside the barrels, or stop the circulation of the water and start to heat the resistive heater. The aim is to really master the temperature and to have a very stable temperature through time to really master your process. The density control unit. I said earlier that the density is really important for fish feed production because it will determine the behavior of your pellets in the water. We developed something that we call the density control unit. So the machine, you will set in the machine a density, a target density, and then the machine will be able to adjust automatically the steam injection to lighten the density, or on the other hand, to start the vacuum degassing inside the machine to increase the density, okay? And it will be able to calculate the steam injection, the throughput of steam we need in the machine to achieve the right density, and the power of the vacuum degassing. So this presentation is almost reaching the end. So if you have to remember something from this presentation, it will be that we saw that there are great opportunities for fish feed production on the market because the aquaculture production is growing in a global scale. But also the way that we will be producing our pellets has changed. So now we are going to use more complex formulation to comply with the label, with the certification, the sustainability, and so on and so on, and the twin screw extrusion technology. And what we can offer you will help you to face all those challenges to make a qualitative fish feed that will match the needs of your species in terms of size, texture, the density also, the digestibility, the storage, and so on and so on. So what's the next steps? So as I told you, at Klextrol it's not about just selling extruders. We are really mean to support our customer from A to Z. And we have, as I said during the introduction, we have a really wide R&D network, okay? So if you want to discover what is our technology, if you want to develop new application, new product, new shape, and so on and so on, we are really happy to welcome you to one of our facilities. We can work on all the different applications, so the protein, the snacks. We can do also, of course, the fish feed and also the pet food. So we have places all over the world to do that, but if we focus on the region, we can do that in Australia. You can come to Singapore. We can do that in Bangkok as well. So maybe that would be the next step for you. And also, so that's something that we are releasing like just right now. It's a really exciting event that we are creating in Singapore by the end of May. So it will be the Feed Extrusion Mastery short course. So the aim of this short course is to give you 3 days to master the fish extrusion processes. So we will give you a live demo on an EV25. We'll study, because you just saw maybe 10% of the influence of the parameters and what we can do with an extruder. So the aim is to go deeper in the topic and to see the influence of the parameter on the final products, the raw material use, and the production line management. But what's really important and what we think is also a good thing is to bring together many different experts. So we'll have industrial with us, we'll have researcher, coaching experts, and so on and so on. And the aim is to really create an ecosystem to share the knowledge. So if you want to know more about extrusion and also like be able to network with all those experts, you can flash this QR code, you can register, and then we'll be able to send you some more information afterwards. So we'll be having a booth this week at the VIV, so do not hesitate to come talk with us if you need anything. I would like to thank you for your attention. Here are my contact details, so if you have any question, if you need anything, if you want to book a trial, do not hesitate to flash my WhatsApp number. You can also send me an email, and we'll be happy to support you in your future project. Thank you very much.
Very good. Thank you very much. Good morning. Let's discuss a little bit some topics on shrimp extruded feed. My job is a little bit easier today because we had previously the nice presentation about fine grinding, and also my colleague from Klextrol discussing a little bit of Aquafeed. So I will connect a little bit of these topics. Here my personal information. I'm working for Androids for about 10 years, and I work mainly with Aquafeed and Petfood. Very, very, very quick introduction about my company. I'm not wasting time over here, but they support me to be here talking to you, so you can see here the size of the business we do, the different areas we act, how we are spread around the world, which facilitates servicing and aftermarket. Also here how we do, we can supply from single equipment to the whole plant,
But without losing more time on that introduction, let's talk about our main topic here, which I give you a very brief introduction, what will be discussed. So, very basic introduction on the shrimp feed extrusion process, what is required about nutrition needs on the formulation. Formula is key when we talk about shrimp feed. Then a little bit more into the production process themselves, like grinding, mixing, the extrusion itself, and drying. And I will conclude with some takeaway messages. So here are just the numbers on the market, so you can see how important is the shrimp feed into the aquafeed work. It represents more or less 20% of the volume produced, and also we have some projections here how it should grow within this range, about 5% a year. So it's a very interesting market to invest. Some key points on the formulation: the nutritional, as I told you, so it's about how you're going to formulate, but they are more or less connected: the cost efficiency, sustainability, and water quality. They are a reflex of the technology that is going to be used. We're going to discuss this a little bit upfront, different regions, how we do this type of feed, and some market trends. So basically, this is just an overview for you. When we see the biggest aquafeed market in the world, which is China, most of the aquafeed is still pelletized. When they need to do floating fish feed, for sure, then there's the need for the extrusion, because you can't make floating fish feed on a pellet mill. And we see that extruded shrimp feed is just a kind of a crawling over there. So we see a trend, but in the middle term, 5 to 10 years. APAC, very similar. Most of the feed is still produced on a pellet mill, but in this region, a lot of aquafeed, it's floating fish. Example, we see here in the presentations for, I was in the other room, for the catfish, for the Pegasus, it's more like a floating fish feed, so they need an extrusion. But in the shrimp itself, most is still made on pellet mills. Here is where I live and where I work the most, on Latin, and that was my first introduction to this technology. So I learned how to do shrimp feed with my customers in Ecuador. That for me was the natural technology. And then I got this shock when I started to work as a global application manager and realized here in Asia, in APAC, it's done in a different way. So I came into these meetings with the customers, and I needed to explain why over there we do like this, and why it would be a good idea to start develop this type of business over here. The main difference is in Latin, the environmental regulations are more strict. So I think it gives here in APAC more freedom or more loose to produce in a pellet mill, which is not as efficient, is not as eco-friendly, but is cheaper. So as long as the market allows it, they will still keep producing in a cheaper way, but it will come someday, the regulations. And there is a technology behind the extruded the shrimp feed. So the suggestion is, if you have a chance to start develop this technology, start right now, because when the laws change, it takes a little time to learn how to produce in an efficient way, so you will be on the better spot when that comes to it. When we compare the extrusion technology with the pellet mills, so the main difference is that the extrusion, it's really a kind of a cooking process where we really activate the starch as a binder, and therefore we can create this pellet with a higher mechanical strength. So it will give more water stability. I see here in APAC, they produce with a pound, how we say, high density population of shrimps. Again, because it's still allowed. Maybe these regulations will change in the future. This is not done anymore in Ecuador, which is the main market. So that's what I say. It really cooks the material so we can take the benefits to produce with higher water stability connected with the mechanical strength I just commented. And this is interesting, enhances the nutritional quality of the feed. We can imagine in the evolution of the species, the shrimp didn't evolve to eat corn, for example, as a source of starch that we usually use in South America. So if we give you raw starch coming from the corn, their digestive system will not be able to handle that very well. So when we can cook it, we make it easier, even for them that are not used to digest it. Very beautiful picture of the phases of the shrimp. I was also watching a presentation over there about hatchery. So we can see the different phases, starting with the larvae, post-larvae, the starter, the grower, the breeder. And as the shrimp grows and change its phase in the development, the formulation of the feed will change as well. So usually when they are smaller like this, it's more protein. The content of protein is higher here because they need to grow. And when they come to their finished phase, it's more about making them fat. So usually here the protein is not that important, but more energy in the feed. Very interesting this comment here. As I said, I was watching the other presentation. They change when they are very small, like a larvae. They're gonna be herbivore, so they're gonna eat more algae or plants, and then they change to omnivore. And that's why when we started to use these fish meal sources of protein, and now we are looking for vegetable source of proteins as well, because we cannot catch more wild fish anymore in the oceans. The raw material selection, I didn't bring here any specific recipe because it makes no sense. It depends very much where the plant is installed and the availability of the raw materials. As Professor Mias was explaining, there is this huge chain of raw materials moving around the world. And if you wanted to make with a lower carbon print food, in general, you're going to use the resources that are nearby. But so as characteristics of the formulation is the content of a starch, protein, fiber. So mainly this will change very much on the type of raw materials you're using. Some examples of raw materials: wheat, rice, soybean, mainly in Latin, fish handling a lot. Soy lecithin can be used as an attractor for the shrimp because we produce the feed that go under the water, and the shrimp is moving there in the bottom, and he needs to feel attraction by the feed. He needs to, let's say, smell it under the water. So that could be something, but also the marine oil is very much used for this. And what are the characteristics we are looking for into this type of feed? First, it should sink fast. If it takes too much to sink, maybe it will lose the water stability before the shrimp can reach it. Also, higher water stability because we consider the shrimps, again, I'm talking about those markets in Latin, not so much where we have this high density ponds, because when you have a high density pond, they don't care too much about water stability, simply because they consider it's so much shrimps in the area that they will consume all the feed that you throw in the pond. That's how they produce mainly here in APEC, but when we see into Latin, we search for a higher water stability. How much in numbers? In the laboratory, minimum 2 hours, but it's common to see tests where the feed can stay for more than 1 day, sometimes 2 days under the water, and it's still integer. And for sure, the size uniformity, the size of the shrimp feed, it should match the stage of the development of the shrimp. So the most common feed sizes are 0.8, 1.2, and 1.8, producing on extruder for shrimp. Now we are starting to produce a 0.5. That's a very good application for the twin screw extruder that my colleague was just commenting here. But in general, in Latin, we produce shrimp feed in a single screw extruder. Can it be done in a twin screw? Oh yes, it can. Anything you do in a single screw, you can do in a twin screw. It gives you much more flexibility, but also the investment, the cost of the machine, it's higher. So if you have high fluctuations on the delivery, on the sources of your material, and you need to be changing your formulation many times, then the flexibility of a twin screw is more convenient, but in general, a single screw extruder can produce this type of feeds with this parenthesis that when we go 0.5 or even smaller, sometimes I hear even smaller feed, then it's the time for the twin screw. When we discuss grinding and mixing, basically there are two ways of doing the grinding. One way is more the US, the American way, which is pre-grind everything and then do the mixing. In general, what I see in the plants is more prepare the batch, which you're gonna select the formula of the raw materials in a scale, prepare, send to the grinder, and then later we're gonna do the microdosing and the mixing. So that's what we call the post grinding method. Usually hammer mills are used for that. In Latin America, we can do that 19% below 250 micra using hammer mills and a selective screen. But here in Asia, due to the nature of the raw material used with some more fiber, there is space for the pulverizer. The pulverizer can handle better high fiber inclusion in the raw material. Also, if you have a high oil in the formulation, for example, if you have too much fish meal, then also can be a limiting factor for the hammer mill. Just because if you're working with a screen very small, such as 0.7, you can clog it with this oil that comes from the formulation. So these are points of attention, but again, in Latin America, we work with this system here, double hammer mill and the selective screen. Whatever the selective screen captures come back and is grinded again. But in APAC, it's more common, then you don't need a double. You need just one hammer mill as a pre-grinder and a pulverizer, and that's more common to see here in Asia. So basically this also just adds a little bit of information from what our colleague from Reynolds was discussing here. So in general, we're gonna recommend a double grinding, see the energy requirement it needs, and when you start to work with a pulverizer, then the energy requirement goes very high. As he was explaining, sometimes it's too much energy and then you cannot create a case here. Other thing that's very important to highlight is the wear and tear of a pulverizer is much higher, so it's expected for you to spend much more money on the wear and spare parts using a pulverizer than what you do using a hammer mill. So just some point of attention, but anyway, it's always good to have a selective screw after your grinding system, because you really want to avoid these bigger particles that can block the die plate. It's really annoying to start up a process and in 5 minutes have a blocked die plate. And that happens. That happens many times. And also what I see is these flexible lines, where in 1 week they're producing pet food and in 1 week they wanted to produce Aquafeed. So you gotta have a good method for cleaning your transport equipment, because if you don't do that and you collect these bigger particles from the previous order, instantly it's gonna block your die plate and then you need to stop, clean everything and start it once again. Some comments about the conditioning. It's really key The first extruders, they didn't have a conditioning. They required much more power to produce the same capacity. But when we started to do the preconditioning, we discovered that we can pre-cook the materials and make the job in the main motor of the extruder easier. So under it, usually, general will have a double conditioning, and the top one, we're gonna add the liquids, the steam, to start activating the starch, the cooking the protein, and the second one on top, on bottom, usually is just for retention. We're gonna not add the steam or water in the second one just to give a very good retention time. Nowadays also we have double shaft conditioners, which is a trend in the market. They can do more mixing. So also it's a good idea. And this is very intriguing because sometimes I see the double shaft conditioners on the top and a single shaft on the bottom just for retention, but I also see the opposite. I see a single shaft on the top and a double shaft on the bottom. Then you can argue which situation is better. We can discuss this topic if you want to. You can come to my booth and we can try to find the best solution for you. So just some general information about conditioning. The extruder, which is the key equipment that we are discussing here, this is something we can produce in a single screw up to 0.6 or down to 0.6, let's say like that. But if we go smaller than this, then as I said before, is the time for the twin screw extruder. These are just the comments when I'm compared with a pellet mill, because a pellet mill will not tolerate any moisture in the field. You do not add any water when you do aquafeed on a pellet mill, but when we do in an extruder, yes, we're gonna add at least 50% of water in the conditioning phase, and also the steam to raise the temperature and to start the cooking process over there. It's common to see 3 conditioners in extrusion line for shrimp feed. And I will give you, what I see is the basic way to control the expansion, or in other words, to make a heavier feed that's gonna sink, is by flooding the barrel of the extruder with water. If you put 1% of water, it's gonna help you to expand the product. But if you go beyond that, 3 to 5%, then this water will start to work inside the barrel as a lubricator, and then it doesn't promote any expansion. The problem is you're gonna have a feed which will have a 30% of moisture content, 32, something like that, leaving the extruder, and then you need to dry. So it's extra money on the dryer, which is the equipment that uses the most of the energy. So Androids developed the ECS, which I have here a little explanation about it. Now I see some competitors also work with a similar solution. So basically we pressurize the chamber here with pressure higher than the ambient, usually one bar above. And then we change the boiling point of the water. So in other words, when you have the system on, there is less expansion because there is less evaporation of water after the die plate. So therefore you can have a heavier or higher bulk density in your feed. So working with this, we can do shrimp feed 650 grams per liter, something like that. And the moisture content after the extruder will be around 24, 25. This difference of 6% is a huge difference in the dryer and really pays for a system like this very quickly. You can have a return of investment in less than 1 year. So it's something recommendable. Here is just a wrap-up, a summary of the technologies we can use to produce a high-quality shrimp feed. For example, very basic water cooling. I like what Professor showed here, a very, very basic water cooling. I don't suggest you to go in that direction. We can have water running inside the barrels here. So we decrease the temperature, and then we also decrease the expansion. Barrel venting is something more developed. Our colleague from Klextrol was showing over here, but it brings very good results. What I see from my customers in Ecuador and in Mexico using this is they can change slightly the formulation, and they can produce a cheaper formulation when they have a venting barrel like that, which means basically less starch, more space for nutrients. And they told me they can save something like $10 per ton. So on a machine like that, producing 15 tons per hour, it's very good money. This is something special for microfeed, which is feed below 2 millimeters. So when we are drilling these small holes in a die plate, we cannot make them too close to each other because you will fragilize the die plate, it's going to break apart. So that's the limitation when we have the standard die. You can never use your motor power at 100% because you don't have enough open area. So this solution here works mainly for the small caliber feed. There's almost no gain when we do ordinary Aquafeed 4 millimeters. Change like this, you're going to keep using the same usable area. But when you do these pellets less than 2 millimeters, then because it has a higher working area, you can increase linearly the capacity of the machine. So we got a good result here. You see this difference more or less 40%, and that's what we could achieve as long as you have extra power in your motor. Drying, as I told you, you can easily use 50–60% of the whole extrusion line energy only in this equipment. So it's important to have an eye here and to have this in a very good shape and operating to very good. Basically, we are removing the water so we can increase the shelf life of the product, of the feed we are producing. We have a specific technology that we call the mesh belt used for shrimp feed. It gives advantage on the drying process because it has a very high open area when we compare with the lamella. Can it still be done with the lamella? Yes, the metallic sheet plates with the perforation can be done, but there is a limitation on how small you can punch a hole in a plate. And when you go smaller than 0.5 millimeters, then in general, a conveyor dryer is not good, and that's the time when we're gonna suggest to use fluidized bed dryer. So very specific solution, and mainly when our customers have that, they have a dedicated line only for started feed. Last but not least, it's important to have testing and monitoring of your product and have a rastreability. Also standards and regulations that needs to be followed according to the region you're doing your work, and proper storage. I visited this customer in Turkey in December, and they were complaining about mold in the bags. So you raised the basic questions. Yeah, but do you cool down your product before package? Yes, we do. Do you use a pellet like this under the bag so they do not touch the ground? Yes, we do. Do you keep a space from the bags to the wall? Yes, we do. Okay, so let's take a look. The thing was, the pile of bags were too high, and at the top it was making like this, and the top of the pile was touching the wall. So that's why they were getting mold inside the bags, which is really not good, because when you send a bag like that to your customer and he opens and see the greenish, brownish stuff, there's a chance he will not buy from you anymore. So it's very important to keep these quality parameters under control. Here is a table. I'm not going line by line. It's just for you to, you may take a picture, you may look at this later. It's a comparison between the extrusion and the pelleting line. I think the most important is over here, guys. Usually when you do in a pellet mill, you need a higher fraction of your formula to include the starch that will give you the minimal water stability. But when you work with extruder, you can work with a lower starch level, which in other words, gives you more space for nutritional facts in your formula. Or just to make it simple, this feed has higher conversion rate than that one. So if you fill your shrimp with 1 kilo here, it will gain weight better than if you give 1 kilo of that type of feed. That's the main message I wanted to convey to you guys. And I must admit, when I discuss it with the local guys here in APEC, it's difficult for them to understand here because they are so used. I'm trying to think about this. I think about electrical cars. For example, in my place, we don't have the structure. You can buy electrical car in Brazil, but it's so huge distance. I cannot drive to São Paulo with electrical car. I cannot plug it. So I see this technology like this. Even when I go to Scandinavia, when I go to China, I see most of cars around are electrical. So this is the kind of a paradigm that we need to change. And I will need to drive an electrical car maybe in 5 or 10 years. If I like the noise, I'm a mechanical engineer. But that's just how it is, the word. So just some takeaway message here. I'm able to finish in my time. So, okay, very important. We can have a full utilization of the starch source because we can really pre-activate it and cook it, which will give it the strength and will reduce finest generation. We also give it the higher water stability. No need for additional binders that are required in a pellet mill. So for extrusion, no needed. Less starch, this is what I told you when I was reading the table. Less starch equals more room for nutrients in formulation, which will give you a higher conversion rate. No need for post-conditioner, but needs a dryer after the extruder. And for sure, it's important to control the expansion. There was a customer calling me yesterday. They cannot do sinking fish feed in their extruder line. So I was doing step by step. Do you have this? Do you have this? Do you have this? So they're missing the frequency drive in the main motor of the extruder, which means the shaft is always 100%, too much energy, so they cannot make sinking shrimp feed. So the suggestion or the solution for them, they need to have a frequency drive in their motor. So that's the conclusion of my presentation. Professor now is going to talk, and if you have any comments, you can do it. Thank you, Professor.
Now we're going to talk about some of that advantage of soy in aquatic feed, aquafeed production. Just lost my, I'm gonna do the update. That's okay. Hold on this one. No, it's not gonna work. Okay, I will stand here. I think when I updated some of the speakers' presentation, something happened here. Let me try again this side. Okay. Okay, it's working now. It's always a challenge when speakers bring last minute presentation, they want updated last minutes, and I was doing that one. Anyhow, let's go back again here, talking about soy advantage in aquatic feed. We all know that aquaculture has been the fastest growing segment in agriculture globally for more than a decade. We have seen a lot of activities. We heard this morning as well from different speakers. I'm not going to repeat it. But if you can see there, look at around what's going to happen in harvested wild fish in 2030. And then of course, we're going to anticipate demand for the fish, where we're going to have a lot of volumes, and that's going to come from that, of course, aquaculture. Therefore, there is a bright future for aquaculture, and we need a lot of ingredients. We need a lot of other things to make sure that we have our seafood there. And that growth is because of our populations. If you can see that, population is growing very rapidly as well, especially in China, India, and Indonesia, and of course some other countries. Increasing demand of the high quality product. That means that also revealing our return for that captured fishes. That means we are reducing the stocks there. We need to get some more. Therefore, aquafeed demand is growing rapidly, and for all stages life, and that has grown more than 20 million metric tons annually. And aquafeed, of course, you can see the estimated market as well, just to give you some background. In 2023, and it's projected to grow around 6 to 7% from 24 to 2030, and it's because it's fueled by this growth is fueled by the rising demand of the fish meal for the aquaculture as well. And fish and the feed producer have to be used to replace some of the costly animal feed of animal protein with something like fish meal, which can have equivalent to formulate and also maintain the market competitiveness. And there's quantity and the cost is very going high rise, therefore they have to find some replacement for that. And where that's coming from, that's going to be a challenge here, because we have a almost insufficient to permit continued use of fish meal as a protein source. We need to find some other alternative. What are the other alternatives? It's going to be, of course, soybeans, because of course soybeans, you can see here, they have a balanced amino acid profiles plus bioavailability. They have lower anti-nutritional factors. The US grown soybean, which is processed proper conditions, and they produce from, as compared to different regions, it has much better quality, lower cost, especially when you're reducing or removing the fish meal requirements in the fish feed. You will find much better, easier to find this, and also have better value for that, because it will give you ideal diet, more digestibility from US soy. Therefore, there are a lot of different reasons to be looking for the soybeans, and they're grown especially in the US to replace the fish meal, because of demand is going very high for the fish meal. When you compare different oilseed crops, you can see that again, soybean has much of the largest protein value as compared to some other oilseed. People may be using it in different formulation, but it has much better value when you look into that our soy protein there. And also the beauty of the soybean is, of course, they are grown and harvested all year around, and you can find the supplies all year around. And you can see that when we have a harvesting time, in other countries they will have a planting time, and then other places will also have it. Therefore, basically you can find year-round supply of that, your soybeans, all that. That's the reason we're looking for that. And also, if you look into the crushers who crush that proteins, soy oilseed crops to process meal, they love that one, soybean, because this will give you much better protein as compared to the other one. Some of that rapeseed being used, sunflower, palm oils. When you compare the protein here, the protein is much better into the soybean, and also crushers want to use the soybean, which is that one, it will using it because it's much easier to give them the more benefit for that. Therefore, if you look in the soybean composition wise, and you can see here, I'm sure you are aware of that, they have 38% protein, and then have about 18% oil, and then of course the insoluble carbohydrate, mostly dietary fiber, and soluble, which mostly are the sugars in that one. And soybeans, that we find a lot of different derivatives from there that can be used. We crush the beans, and we can get the soy hulls, the soybean crude oil, soybean meal. Sometimes we use the whole soybean, where we get a fermented soy and cooked, and then of course we can use that byproducts, ingredients go to the animal feed, that which will fulfill our protein requirements. Therefore, it is a crop which can be used for different application for different animals as well. Therefore, you look into that, this is basically typical solvent extraction process, from where we get all different ingredients, soy flour, soy concentrate, soy isolate, soybean meal, and it is a solvent extraction facility where you take the soybean after cracking, roasting, of course, you can get the full fat soy, or you can again further process them, make the flakes, then you defat them, and then of course from there you get some of that soy protein concentrate, you get soy flour, you get DL soybean. Therefore, a lot of different places you can get different derivatives to be used in that our feed application and food application as well. And then that was a solvent one, but we also have mechanical processing. People are small scale, like processing extruders and expellers, and they're using it, are just using an extruder. And also in this case, they have a full fat soybean meal, which is basically not dehulled. Also they can do a regular one, and they can do it with that cold dehulling. Similarly, we have extruder expeller soybean product as well, where they can have it hull or dehull depending upon their application. Therefore, two main methods. Most main method is of course solvent extraction, but also small people also try using extruder expeller, and they have option to either remove some of the oil, or they just use it, we call it partially defatted meal, or they can use this full fat. And then also they have option to dehull them or not to dehull them to increase the level of protein. Therefore, these are different things that we can process from the soybeans. Therefore, if you look again, typical composition of the soybean ranges here. These are the ranges you can find at soybeans for different regions. Proteins you can see around here 35 to 40, average will be around 38, oil can be 18 to 20, average will be around 18.5. Fibers, moisture, and also some other carbohydrates there, you can see all that. Therefore, these are the ranges you will find it when you try to formulate your feed. Therefore, U.S. soybean industry has worked to develop, promoted the feed that's based production technology and high quality soy-based aquafeed for freshwater as well as for marine fish, and that's when we're trying to meet the need of our protein deficiency, protein requirements for that fish feed. And of course, the nutrition quality of soybean meal make it very effective source, quality protein, very good amino acid profile, and of course that fulfill the requirement for all stages of the life of the fish. And of course, the current estimate shows that more than 20 million metric tons of soys are being used in aquafeed today, different forms. It could be like in a meal, it could be concentrate, it could be different application for that. Therefore, soybean meal, nutrition-wise, if you look on there, we can have a 48% where we dehull the soybean. We can have 44, which we do not dehull the soybean. Most of the crushing plant, to increase the efficiency, they will dehull the soybeans. And sometime when they can dehull it, get the efficiencies of extraction, they can go back again and add the fiber back again. And soybean meal is very comparable with the fish meal in all the essential amino acids, except of course we all know that lysine and methionine, which can be balanced with other plant ingredients as well. Therefore, if you look here again, our fish meal from Manhattans and also soybean, and you can see there all that essential amino acids there almost. And then of course only the two of them I mentioned there, they are a little bit deficient, but all others are available in the soybean, one form or another that you can use that even better some of the application. Therefore, soybean meal provide you a high crude proteins, of course balanced amino acids, profiles, reasonable cost, steady supply, consistent composition, and good digestibility. You can find that from soybean meal. Therefore, what are the ingredients are available for us to be used in aquatic feed? We have a list here. Some of them are using it depending upon availability where you are. We have a full fat soybean meal, we have a soybean meal, we have soy protein concentrate, soy protein isolate, we can use some of the hulls, soybean oil, soy lecithin, fermented soybean meal. All are the ingredients from the soybean crushing or mechanical processing that can be used in aquafeed for different formulation depending upon your need. Soybean meal can effectively replace, of course, majority of the fish meal I mentioned earlier, mostly that used in carp, tilapia, catfish, and some other freshwater species as well. Soybean meal can serve as a primary protein source in all plant-based protein grow-out rations. And of course, sometimes we can replace 100%. We don't even need a fish meal there, some of the formulation as well. Full fat soy, as I mentioned, you can dehull them or you don't have to dehull them depending upon your setup. High protein content, 35 to if you are 40, depending upon if you are dehulling it or not. Fat going to be around 16 to 22%, depending upon how much moistures are there. The full fat soybean generally are less expensive, of course, sometimes in soybean meal because you're not extracting the oil. Therefore, you can use that which has the oil as well as your protein that can be used in some of the formulation. Mechanically processed, where I mentioned that where you don't use the solvent extraction, you can also process your meal. It will be high in protein because we remove some of the oil. Therefore, protein can go to 40 to 46%, fat about 6 to 10%. Fiber will depend upon if soybean were dehulled or not. Moisture around 78%, and this is the process where you can process that and remove some of the oil out depending upon your feed formulation, what you want to use it, and you can basically apply that as well. Then we have also here called the soy protein concentrate that is rapidly becoming a cost effective. Remember that there are the food grade concentrate and there is a feed grade concentrate. We're talking about feed grade concentrate which is less expensive and they are of very high level of protein and therefore they are minimum level of anti-nutritional factors and high quality protein substitute, and usually it is around 57 to 65% range. For that demand for the feed grade is growing. I see a lot of facilities coming up. I think one in the US and one or two in Brazil. They are coming up and they are processing soybean for the concentrate to replace, of course, the fish meal as well. And this is one of the best replaceable ingredients that we see that are working very rapidly in the aquafeed industry. Then you have soy isolate, which is the highest pure form, which is around 90% protein. And of course, here we remove all our non-protein ingredients, especially we remove all the soluble carbohydrates, all the sugars there. And of course, it can give you very, very good quality protein, improve the feed efficiency. They are easily digestible, high protein utilization rate, and of course, enhance palatability and improving its flavor and aroma. Therefore, this is the highest pure form of that protein soy isolate that you can be used. Soybean hulls can be also being using it. That typically special application, especially grass carp feed, and of course, sometimes non-dehulled meal would also have these ingredients in the soybean meal. But sometimes we will have this one. Mostly we send it to that cattle and other feeding for the feeding. But again, sometimes we can also use in some of that formulation, which is grass carp there, that we can use that. Soybean oil, that's the best of the oil that we use most of the aquatic feed because of that high linoleic acids, and that is very free flow. Most commonly we use for our coating system when we do the aquafeed. That's where we use that. It provides all the essential fatty acids, and sometimes we even add some of the other additives into it so that we can do proper coating. And also soy lecithin, a mixture of the phospholipids and triglycerides, relatively inexpensive source for the phospholipid, that also use it. It helps to emulsification of the fat and also reduce the leaching of the water soluble nutrients. Sometimes we use in the coating also. That will give you much better result. Therefore, there's every ingredients we use that one. And the last one is fermented soybean, which is coming up very quickly to all the places. Fermented soybean meal is produced by inoculating the soybeans, the whole soybeans. Therefore, using some of the very special fungi and bacteria, Aspergillus or Lactobacillus. And then, of course, fermentation improves the digestibility of soybean meal, reduces the anti-nutritional factor. And of course, fermented soybean meal can increase the growth rate, feed efficiency, and also it improves the gut morphology and gut microbiology and also intestinal health, because they are all very good for that, their gut health. And also fermented soybean meal can increase the fish immunity and produce antimicrobial peptide. The way we do that one here in this case, we have that grown soybean meal, we add the water into it, and when we inoculate, we control temperatures. And then of course we add some growth factors there, because 48 hours, we add some enzyme mix into it. And then of course we leave it there, and then we, of course, after that liquid extraction, filter it, low temperature, then we dry that one, we grind it, and then we use it. Therefore it provides a lot of different benefits, because in this case it improves our digestibility, and also there is we remove all the nutritional factor from there as well. And this is the one which is also getting very, very popular now in that aquatic feed, because this is providing a lot of benefit there for especially the health of the fish. Here I put all our ingredients together and give the comparison. You can see here soybean meal, full fat soybean meal, soy protein concentrate, fermented soybean meal, and soybean meal isolate, all there. You can see here the dry matter, the moisture one, crude protein, also the fat, their energy level and ash, and of course essential fatty acid there. You can see that. Therefore, depending upon where you are, what is availability to you, what's the cost effective, I'm sure that one of that ingredients can be used, some of that soybean base that can replace some of your cost from that, especially using the high cost of the fish meal and some other ingredient as well. Of course, when we formulate this our soy-based ingredients, we always use the least cost formulation, and especially in dehulled soybean meals is used because of the better protein values and the lower fiber content in that compares 44%. And therefore, basically, what most of the formulations are now based upon least cost formulation, where we can add the value for that, and then we can get our formulation based upon that. Therefore, to just summarize this portion of the talk, benefit of using the soy in aqua. Number one is that it has a very superior amino acid profile, consistent quality, it's verified sustainable sourcing through the soy sustainability assurance protocol. We'll talk a little later about that one. Very fine texture, easy to grind, and of course you provide you technical support, the only commodity of the soy that provide technical support. In case you are an aquaculture farmers, you need to get some help And I'm sure that some of that, I think Yusuf has a booth here as well. You can go there and talk with them, and they have a consultant. They will come and help you to formulate. I'm not personally a nutritionist, but I know they have a lot of nutrition on their staff, and they can help you to formulate that, any of the ingredients you are using there for different application. I talked about sustainability also, and the first talk was also, I mentioned about the energy and also reducing costs, and also sustainability is also part of that. And US soy industry is very, very particular improving their sustainability, a key differentiator to the soybean industry, because they are focusing on mostly sustainability. And basically, they are sustainability from globals and aquatic perspective, we will talk about it, and then soy sustainability and reducing environmental impact. And then we talk about also our assurance program there for the use they have there. Therefore, basically, what that means when you say sustainability? That means we are providing our social goals that are broadly aimed for the human to safely coexist on the planet. We don't want to damage all our planet because we are growing a lot of crops and we are not taking care of that. We want to take care of our motherland. We want to take care of our land as well, planet Earth, over a long time, because our generation is going to come there. And therefore, we don't want to deplete all our resources. We want to make sure that our crop there. Therefore, if you look over there, there's a goal there, and from there, the U.S. soy farming, our industry there, they have developed this specially goal, reduce the land. Of course, they did that one, reducing the land by that impact by the 10% land uses, reducing the soil erosion by 25%, increasing energy uses by 10%, and of course, reducing the greenhouse gases by 10%. That is the goal, because we want to make sure that we live in this environment. We want to be safe on the same side. And if you look over there, again, we talked earlier, global wild fish capture, and then of course how many million tons they are. Therefore, sustainability in the aquaculture value chain began with the raw materials, and we need to use in the feed. Therefore, we want to make sure that we have enough raw materials, so we are much more have the sustainability in the aquaculture. Otherwise, we will not have the raw materials there. And this is what just to show you that, of course, demand for the Aquafeed and the fish meal from 2015 to 2025. And here you can see they are taking fish out of the fish feed, can make aquaculture more sustainable. And then, of course, next one is the environment, that how we are helping the environment, soy sustainability. As the soy ingredients becoming a significant part of that production process and Aquafeed, it's therefore natural to focus on sustainability and reducing environmental impact. Of course, you can use a lot of soybeans, we grow there, but at the same time, we want to make sure our environmental is having the safe, reducing impact. And this is the comparison. You can see carbon footprint for the whole soybean of different countries, and you can see here United States, Argentina, Austria, and Brazil, and of course United States providing that minimum carbon footprint. I talked earlier this morning on my talk as well, and this is the one which we are saying that we are producing less carbon CO2 there when we grow, because of we take care of our special practices, and that reduce our carbon footprint in the United States. And here you can see again feed production is important, greenhouse gases again. And you can see here for the salmon, and feed is the most important part, include the land uses, the crop cultivation, we have used the feed, and that will be like this much is that we can produce the greenhouse gases that our goal is to reduce that one, and therefore this is just to show you how much it costs greenhouse gases to do different things there. And then last one is the US provide you assurance of the protocol. That means it is not only measured by an arbitrary threshold, but on the same time they provide commitment, innovation, and continuous improvement. And what that means is that here is that they did it on last 40 years, from 1980 to 2020. They committed to that we have, of course, reduction 60% irrigation water, 48% land uses, 43% greenhouse gases, and 46% energy uses, and 34% soil conservation. Therefore, the US farmers are very, very careful when they do that, their cultivation, because they are concerned about greenhouse gases, they're concerned about, of course, also carbon footprint, and therefore they assure that we are much more sustainable if you're going to use the US soybean in your aquatic feed. And also, it's not like that only, they can give you a certificate where you will be proud of that. You can see this kind of certification on the soybean ingredients that's transferable. That certificate basically tell you that this was verified Of course, the supply chain, measurable continuous improvement goals. Of course, there's mass balance, conservation and national scale, all these factors. They look into it, and then of course, then they will give you the certificate there that our soybeans are, which are more sustainable, and then they use that. That's the advantage you get from the US soy industry. Therefore, conclude my talk, what's the key message here? The key message here is for the US sustainability and a key differentiate for the US industry. That means aqua farming for aquatic animals for the food is fastest growing. We talked earlier. There are limited resources. Commitment to innovation, sustainability is not measured by an arbitrary threshold. If improvement, plant protein, with the switch to the plant protein sources, we need to have new knowledge, become very critical, which is research. And then US advantage is that we are using a US soybean based upon national system, sustainability and conservation law, and therefore we provide a certification or sustainability and focus on that in very rigorously on that one. With that, my time is up. I will be happy to answer any question if you have it.
So if you have any needs around soybeans, please let us know. So guys, well, first sorry for having missed most of the presentation, if not all, but I had a good reason, which is that we are rolling out this new segment at CPM. So I'm relatively new at CPM, Olivier Dréan, about 15 years in Asia. The last, prior to CPM, I was working with Clestrap, two of my former team colleagues here, Rizzo and Camille, who did some presentation in the morning. Joined CPM in October, so to launch this new segment. For those of you who know CPM, they know as well that we've been in the pet food application for some time. Now we're trying to roll this out as a complete new segment. And this presentation is like the first one we're doing. It's a lot of new, if I may. So our goal, our ambition, of course, is to move towards high quality, durable, cost-effective pet food turnkey processing lines. So I'll try not to bore you too much with a few slides on the CPM, but I have to do that. Then I'll give you some cool market insights, stuff I dig in that I found pretty interesting. Then we'll move to the equipment marks, in particular extrusion systems, dryer, coating, and I'll have some goodies at the end. So CPM, I guess quite a few of us probably already know us. So we're an American company. We are usually, whenever I visit a factory, there is usually a CPM equipment somewhere, quite often our flagship pelletizers. We are number one in some sub-segments, so we're mentioning oilseed. We did not do it on purpose, right? Animal feed and thermal processing. We have a global footprint, so being an American company, quite strong in the US, but not only, very strong as well, very strong manufacturing capabilities in China and Europe too. And we see ourselves as an innovation driver, etc. On the right side of this slide, you can see a few of the equipment we are doing. So triple pass dryer, these are for snacks application. The drum coater, this one is used for pet food or Aquafeed as well. Waffle system. The extruder here that you see is based on a compounding extruder. Our motto is feeding, fueling, and building a better world. And that translates into the three main categories: so feed solutions, fuel, build. So in terms of feeding solutions, we are into animal nutrition. So that's what we are discussing today: animal feed, aquafeed, and pet food. Consumer food processing, again, we see here specialized extraction, and plant-based proteins, green energy, biogas, biomass, and renewable fuels. And then in the build solution, so we have a twin section here, advanced materials. So those are also used, done by extrusion, so compounding, rubber, waste and recycling, and sustainable packaging. That's our packaging division. Global presence, so I've already mentioned that, very present in the US, Europe, and China, and some other geographical footprint. Well, I forgot to mention that I myself am based in Asia. My role is global, so we are quite a progressive company with our leadership team spread out around the globe. In terms of expansion, I'm not boring with all the acquisition, but CPM has grown as a lot of organic and inorganic growth by acquiring a lot of companies. Some names you may know, so like the main CPM name is the CPM Pelletizer originally that we've kept. We've got more than 100 years of experience. And in the latest acquisition, more related to our discussion today, so you see Bliss, that's the Hammerville, the upstream part in 2021, IDA, the Taiwanese company, in 2023, and the latest one, we've acquired Jacobs, which is very strong in aftermarket for thermal those same spots. Our brands, so 18 great brands, some of which are relevant to our discussion today, some are less. If you see Royal, they're the #1 extruder manufacturer in China for compound. And we, like the idea of this new pet food segment is really to leverage on our forces. So we use this manufacturing base. Wolverine, Procter, and Planet are key top actors in thermal applications. IDA has some really great tool in shrimp, for shrimp pelletizer, for instance, and others. So that's the way we are developing this new segment, basically by connecting the dots between our existing brands and taking what's best in order to offer a complete solution. Our markets, so here will be a repeat of what we said before, but animal feed, aquafeed, plant-based application, oilseed, rubber, whatever, you name it. We strive, we really strive, I think like all companies said that's really a very important goal for CPM, to be seen as a partner and to be able to have a full life cycle support. So that's really something we are rolling out. So from greenfield and new equipment to upgrade and manufacturing, training, testing, after parts service. We want to be the one-stop shop for our customers and partners. So now moving to our main topic today, to pet food. A few key insights, some of you might already be aware of that. But first, pet food market value, so give or take, is about 150 billion USD. This was last year with a CAGR annual growth of about 5% per year. So that's clearly a juicy market. The trend is up, all green. In the US, last year as well, or in 2023, more was spent on pets than on childcare. And this, we see this trend as well, translating more and more in mature economies, but not only. The COVID effect here was very strong. We've all lived through COVID, and between 2019 and 2023, that category, so the pet food category, went up by 11% on average, which was to be compared with 6% in terms of consumer spending during that same period. That's in the US again. And if we compare to the current one, we are 2.5. So there was a massive increase that had been compounding during the COVID. And well, all of us, all of you, like some have done maybe some baking to do some croissant, or some others might have done some gardening. Some of these activities, you may have kept it or not, but if you adopted a pet, usually you've kept the pet, so all these growths have stayed. Well, I hope that you've kept it, if so. Another interesting insight as well is like the importance in the total revenue of some of the food giants. So here, just to name a few, like Nestle and Colgate, they revert 1/5 of their revenue from their pet divisions. So the other mega trend that we are seeing is pet food going to more premium product and a pet humanization. So, well, the pets are becoming more and more of the family. We talk of pet parents more than masters. Like there is like toys and grooming. If some of you travel to Japan or Korea, you may have seen those little strollers and realize that it's not a baby inside, but it's a nice chihuahua, well groomed. And it's actually it's backed up by some data. Like there are more baby strollers sold in South Korea for pets today than there are for babies. As you know, it's like South Korea is one of the lowest natality rate in the world. And in terms of food, of pet food, again, that transfer into like more premium diets, more exotic, more interesting ones, grain-free, organic, high protein. Could be plant-based as well, and the shift towards sustainability. So whether for the sourcing of ingredients, and actually Mian mentioned quite a bit of that in his presentation as well before, and eco-friendly packaging. Another interesting trend is like we see in some countries, like we see more pets, but shrinking in volume. So that's in terms of pet food, obviously, also translates in terms of lower volumes. Now the shift towards integrated manufacturing, so that won't surprise most of you here. So clearly what our customers today want, they want like the whole solution from the grain to the packaging to the product. There is clearly a strong push for efficiency, so while customer really wants affordable equipment, they also want to make sure that their production costs keep low, high quality, and to make sure that they can adapt very quickly to the different trends. So key drivers here: technological advancements, automation, robotics, growing need for customization in pet food products, need to be more flexible, and also like the last aspect would be regulatory demands for sustainability and traceability, which are more and more important. So why CPM pet food? Well, we're trying to answer like the previous slide, hopefully. So by bringing solutions and not product, we want to bring systems to the market, being a single source provider, supplying global support. We have our own dedicated automation division, already working in the US actually on significant project in pet food, fish feed, feed mill. And in terms of innovation, we intend to become one of the main actors in pet food. We will launch an innovation center for pet food, in particular in Asia, by the end of the year. So that's the project. So in terms of product category, well, we're aiming at the main volumes here. So the regular dry kibble, round and brown for dog and cats. And then slowly but surely towards premium products, the higher animal protein content, more original ingredient sources, and higher fresh meat injection. Here are some examples of formulation. So, meat meal could be part of the chicken, soy protein, cornmeal, poultry, beef pulp, some vitamins, whatever. The capacity will cater for will be low, mid, and high. That's how we'll define it. So 3, 5, and 10 ton per hour systems. And the moisture content usually for this application will get about 20+% outside of the extrusion and down to a bit lower than 10% out of your dryer. So today, pet food for CPM is already a reality. So since I worked for a French extrusion company for many years, we put a little heart in the extrusion system, because this is where the magic happens. If you less extrusion part in a pet food line or an aqua line or whatever, it will be quite hard to get a nice product. So from the left side, the silos grain to a happy customer. On the right side, quite a few process sections and equipment, intake, dosing, and batching, mixing and grinding. So this we got it covered from our colleagues from Greece and others. Extrusion. So last year, at the same time, we've launched and rolled out our new extrusion system. Drying, so that will be a dual pass dryer, we'll talk about that later, and coating and cooling device that we are also having in our portfolio. And full aftermarket solution, so we already sell to some of the big names, even to some of our competitors, some screw elements and barrel modules. as well as automation capabilities to have all that nicely automated. So, extrusion solutions. So here we emphasize on 2 main points that are many features in the extruder, some of you know. But the 2 we are emphasizing would be energy efficient design. I have a few slides on the motor, so the permanent magnet synchronous motor that we have, and enhanced gearbox technology. So as some of you know, the gearbox is really the critical part in an extruder. Usually as well like the costliest part of an extruder. And a nice quotation. I like to know this. I did it actually a few weeks back in the Beijing. It's minus 12 degrees in the Hebei province, which is one of the main provinces for Petfood. And that's a happy customer who got delivered like that, that new extrusion system for us. So again, new extrusion system for Petfood, but based on years and on our number 1 position in China in extrusion compounding, so which enabled us to have a very good quality equipment at an affordable cost. So our patented motor, the water-cooled permanent magnet synchronous motor. So with 3 main goodies. So first one is energy saving. So by different measures we've done, you can earn about 10% less energy in your consumption. So that's very significant when you compound it in a year or more. The motor itself actually looks very tiny. The first time I saw it, I told my colleague, I think you got the wrong motor because it literally looks half the size and it's 50% smaller indeed. And the last point that is interesting is a strong noise reduction by around like 30%. And for those of you who work around factories, that's a good one to have. Our drying solutions. So for the design and the development of that new dual pass dryer, so we're basing ourselves on the experience of more than 200 years from Wolverine Proter. And so we are rolling out that modular dryer with key features, precise moisture control, easy to operate, modular system, etc. Flexible heating option. We will start with steam at first. So some of the general design here. Nothing out of the ordinary, but a very sturdy design, sanitary, allowing to have a consistent and uniform products. Very durable equipment, energy efficient, and completely automated. So here you can see the different zones with the dual pass. So the modular design will enable us to cater to different capacities. And moving to the last main block of the standalone equipment we are rolling out in order to complete our turnkey lines, the coating solution, so either on the left, the drum cutter, or a vacuum coating solution. So, coater, as you may know, to coat with fat, oil, flavors, and other ingredients. For our vacuum coater, main features, like a very deep penetration for better absorption, thorough and multi-step mixing, and a durable design. And a few slides on service and support. I've mentioned that already, but that's very important to us. Having direct access to the team, true partnership, comprehensive customer care, in order to accompany your journey. And so, like we're doing that actually on our own equipment or competing equipment. We're quite versatile and pragmatic. But obviously, like equipment installation, commissioning, training, different sort of service agreements, part and supplies, audits, etc. You name it. And automation, again, that's a part where we believe that we are very strong, having a dedicated entity for that. That enables us to basically cater to audits with complete facility automation, user-friendly interface, advanced data, predictive maintenance, etc. We're even working now on AI and automation. Everybody works on AI or wants to work there. And innovation, as mentioned before, we'll have our nice little center by the end of the year, up and running normally, like ready to receive some customers for trials, demonstration, training, and so on. And with that, I conclude that presentation. I forgot to add the contact. So the contact email is petfood.sales@cpm.net. And if not, I'll be with my team at the trade show. I think we are booth 30. Thank you very much.
Good afternoon, ladies and gentlemen. First of all, I would like to say thanks to Dr. Riaz for the kind introduction and for organizing this valuable event. For me, it's a really great honor to be here and share some insight about this topic that is critical for the advancement of the aquaculture. Also, I would like to extend my appreciation to all of you for taking the time to join this session. So no matter you are researchers or feed producer or aquaculture professionals, your participation highlights the growing importance of this macro pellet in the industry. And yes, my topic here is minimizing the size of extruded macro pellet for young fish. My name is David Ma from FarmSound. So I would like to give you a very brief introduction to our company, just in case there's some of you maybe not familiar with FarmSound. So we are an integrated solution provider. So we provide the main machines for the factories that making feed. For all kinds of feed, Aquafeed, Petfood, poultry feed, and we're not only a solution. We are not only a machine provider. We also provide automation. We do commissioning. We do construction. We do aftermarket service, mainly in feed milling and pet food industry. These are just some numbers that hope can give you some rough idea that how we have done in the industry. Now we have delivered more than 5,000 factories worldwide in feed milling industry, and for pet food industry we have built more than 200 factories. In China, our market share is more than 70%. Alright, let's move on to the main topic. We will explore these 4 areas. First one, we will look into the market trend of the microfeed, and followed by the solutions to make micro pellet. The third part is the most important one. I will go through some critical control points in the extruded microfeed production. And the last but not least is about some applications, some photos, some data for the production of microfeed. Most of them are from FarmSound and our customer. First question is, why do we need to make micropellets? As we know that all animals, including the fish, shrimp, they will grow through various life stages, from eggs to fry, to juvenile, and to finally to the adulthood. Right? Actually, in the wild, the small fish, the young fish, and the shrimp primarily feed on the microbeans, like various microorganisms and planktons, like rotifers, like copepods, brine shrimps. Well, there are many advantages for this natural source of microfeed. For example, the they're small in size, but they are nutritionally rich. They are highly digestible, very environment friendly. But they are also have limitations. One of the biggest limitation is the supply and the production of these microbeans is not stable and insufficient for large-scale aquaculture. The reason is that we still don't understand the population control mechanism and quality control mechanism, so it's really difficult for to increase the farming density of these microbeans. So that's also the reasons why the artificial feed becomes necessary. Well, in practice, the farmers will use both the natural source of microbean, natural feed, and the artificial feed at the same time, supplementing each other. This is a photo that rearing a baby shrimp. Actually, it's a greenhouse, as you can see. It's very popular in China. At the very early stage of the rearing, the farmers will feed the baby shrimp with the microbeans, and when the shrimp grows too big enough, they will switch to artificial feed. And the artificial feed at this stage is often referred to as start feed. But there are also many advantages for the start feeds. First of all, the supply and the production of the start feed is stable, because for artificial feed that we can produce under controlled conditions. And also, secondly, we can design the formula to make sure that the start feed can meet the requirement nutritionally. For example, the start feed are always designed as high digestible and high palatable to ensure a higher survival rate for the baby fish or baby shrimp. The other a special requirement for the start feed is the size. Basically, we would like to make as small as possible for the start feeds, as long as we can get a certain level of water stability. So that's where the challenge is. Well, from a business perspective, producing a microfeed has strategic importance. The aquaculture industry has been growing rapidly with increasing global demand for high quality shrimp and fish. And for a company, it's also very important that you can produce microfeed. There are many benefits. For example, you can make more profit by offering this high value added product, and also you can train. You can help the small fish and small shrimps to adapt to your grower feed. So such you can increase the customer stickiness. Also, in some areas, it can also enhance the leadership of the feed producing technology, and sometimes it can support your own shrimp or fish breeding business. Well, okay. Now we know that it's better that we produce more and more microfeed, but how do we do that? So the second part, I'll go through a very brief introduction to several technicals to produce microfeed. There are multiple technicals to produce microfeed. As this chart demonstrated, as you can see here, the light gray indicates the particle size that can be produced by the corresponding processing. So you can see before, if you are going to make particle size less than 0.6, you go for crumbling or you go for spheronization. Okay, so but in the past few years, more and more people, more and more feed manufacturers and all equipment provider are using extruder to making micro pellets. So this is what I'm going to talk today. Including function, that the particle size that can be made from extrusion, it's getting smaller and smaller. So how do we do that? I'll cover how do we do that. I'll cover from the third part. Well, why the extruder attracts more and more attention from the players in the industry? The reason is that the micro pellet making from extruder has a lot of advantages. For example, they have higher starch sanitization, they have better water stability, so they have less nutrition loss, they have less environmental impact comparing with crumbles and sterilization stuff. Well, the second part is the main equipment that's used for sterilization. So basically, a cold extrusion process is required before the sterilization, either through the ring die or the flat die after a single or twin screw. But on the other hand, as you can see here, so the machines that used for producing micro pellet using an extruder is, the machines that are almost the same with that you use to make the normal sized pellet. You see, we are familiar with this part, hammer, polarizer, a sifter, rotary sifter, extruder, dryer, cooler, vacuum cooler. So these machines are almost the same with the processing that making normal sized pellet. Well, also the flow diagram, the flow chart is also very similar. It looks similar. Grinding, sieving, mixing, conditioning, and so on. But there are indeed some additional critical control points that you have to pay attention in order to make a micro pellet. For example, you need to find a way to reduce the die hole blockage. That means that you have to pay attention to the particle size control. You have to carefully to use the ultra fine sieving before the extruder, and after extruder you have to find a way to reduce the pellet linkage after extrusion, because the micro pellets, they are easy to flow, they are easy to link, they are easy to be gone with the wind. Alright, the third part is we will go through some critical control point in extruded microfeed production. The first point I would like to say is the recipe and ingredient. When design the formula, there are many considerations that you have to keep in mind. Of course, you have to make sure that the feed can meet the nutrition need for the small fish. And also we have to consider the water stability, the buoyancy, floating or sinking, or or slow sinking. And also you have to consider the processability. When I say processability, I'm referring to the die blockage, because for the most important difference between the micro pellet and the normal size is the die hole size of the extruder. So the big particle in the extruder mirror, in the preconditioner, or in the transportation system, will eventually accumulate before the die and block the die hole eventually. So that's why we have to remove the impurities, remove the big particles as much as we can. And then for the selection of the raw materials, you also have to consider to choosing the low fiber ingredient. I have some experience. One of our customers they would like to making 0.3, 0.4 millimeter die whole size pellet, and they don't use any soybean meal, for example. Instead of using this soybean meal, they replace them using SPC, soy protein concentrate, or sometimes corn gluten meal, to remove the fiber of the ingredient. Yes, the second part is we will several equipment that's used in the processing. Particle size control. These are our old friend. Okay, hammer mill, pulverizer. For hammer mill, the smallest screen size is 0.6. For making small pellet, it's not enough. So a pulverizer is a must. It's a must, and the particle size can easily go down to 99%, passing 100 mesh or even 150 mesh, according to the measurement. After the pulverizer, you have to put a screen, a sealing device, applying sifter, rotary sifter, vibrating sifter, round sifter. It doesn't matter. What matters is the screen mass. In this case, we can refer to the 1/3 sample to calculate the minimum requirement for the sieving mass. For example, you are making small pellets with die whole size 0.5. So with the sieving mass, we recommend is 100 mass in the sieving device. To make sure that all the particles entering the extruder barrel is less than 0.15 millimeter. This is a curve, very interesting, that you have to keep in mind. You have to be aware that the screen blockage is very normal, it's unavoidable. Let me see. In the sieving section. So this is the sieving capacity. This is the production hour, production time in hours. As you can see here, the sieving capacity will decrease as time goes by. So the next time you choose the sieving device, you have to choose a bigger one, just in case that you are going to use a smaller mass in the future. This one is about the conditioning. As we know that the preconditioning time is very important. Here we recommend the complex conditioner, then with a single cylinder plus a DDC, and 3 minutes preconditioning time is the minimum. And also stable feeding is very important for you to make a consistent size and shape for your micro pellet. So here we recommend the accurate lossy weight system to make sure that the dry material feeding rate is stable. And also the screw and the die configuration have to be optimized for this scenario. For example, the amplified die design is usually adopted to ensure a higher capacity and to ensure uniformity for your final product. Also, high-speed cutting system is essential because during the production of microfeed, you have to know that the die hole is gradually it will be blocked one by one. So as time goes by, the velocity of the material coming out of the die hole will faster and faster. So in that case, you have to speed up your cutting system to make sure that you always get the consistent length of the particle. That also means that you have to check the particle, the pattern shape more frequently than in the normal production. The dryer. For the production of the micro pellet, we recommend this vertical dryer for better cleaning and less residual materials. The key is the hole on the belt. As you know, as the gentleman from Andrew mentioned that there is a limit for the size of this the metal belt. But here in Samsung, the smallest belt hole size is 0.28 millimeter. As far as I know, it is the smallest on the market. But at the same time, also the belt hole is very small, but the opening rate of this metal belt is relatively high because there are more numbers on the plate. What's more is, as you can see here, the hole is like cone shape. This design is used to reduce the blockage of the pellet stuck in the hole to remain higher opening rate for the belt. This is a picture that I took for the belt. Also for the cooler, you need to upgrade the structure carefully to make sure that there's no linkage of the micro pellet inside the cooler. It's all about the manufacturing accuracy. You need to that there is no gap, there's no tolerance between the two swiveling plates. As you can see, when the gate closes, you have to make sure that none of these particles can go out, go down through this gap of the swiveling plates. Okay, as I mentioned that die hole blockage is the most common reason that interrupt the continuous production in micropellet extrusion. Besides the particle size control, there are also some principles that you can keep in mind to avoid the die blockage. So I'll go through these principles quickly. So firstly is we always recommend our customers to build a dedicated line for making the small pellets. Do not, unless necessary, do not share it with the normal sized production because the big particle may stay in the processing flow, stay in the bucket elevator, square elevator, screw conveyor, the canister everywhere. So that if you share it, the next time when you make the small pellet, you will get very bad problem of die blocking. And also in the production line design phase, grinding is important. You always need 2-step or even 3-step grinding. And applying safety outer port is a must, as I mentioned. And also here is a little tip that you can put 2 parallel seating devices in one production line because, as I mentioned, that the screen inside the screen inside the appliance shifter are very easy to block. So if it is happening, please switch it to another shifter, so you don't have to shut down your extruder. And also the water and the steam and the oil that entering the extruder barrel have to be filled with at least 100 mesh. Before each production, please thoroughly clean the system using superfine powders to make sure that no big particles entering the extruder barrel, especially when you produce the big particle, during your last production batch. Check the product shape and uniformity more frequently than normal sized product. Also check the field screen regularly during production. If any blockage, switch to another one and change the screen. And also we have to train the operators to get prepared for the die blockage, because it happens like more than the normal production. Be prepared to react immediately once the die hole are blocked, and make sure that there is at least one spare die plate ready to be used on site. Of course, you can develop your own power tools for the quick reaction, for quick changeover, for quick change of the die plate. This is a very little technique that developed by Samsung team. It's just an example, okay? So when we clean 0.35 die plate before, it cost us 9 hours. And then we used the dry ice technique, and the cleaning time reduced to 1 hour. Just a little tip for you guys. Of course, after the production, you need to strictly clean the whole system, especially the preconditioner and the feeder. That's a best practice that it's very good for your next production. Alright, last but not least, we will see some applications for the making the micropellet. This first one is for the sterilization. We conducted this test on last September. This is the smallest that we have ever made by sterilization. The 0.15, as you can see, die hole 0.15 millimeter, the granule size 0.15 millimeter, and this is the I think we conducted this like 2 or 3 years ago. For the hot extrusion for the micropellet, die hole size 0.6, pellet size 0.9. I think it's floating. Die hole size 0.5, pellet size 0.8. The speakers are using die size 0.5, making sinking and floating. When you make it floating, the expansion ratio is around 1.6, 1.7. So it's subset, 0.8 millimeter for the floating particle. And here the picture is from die size 0.35. Pellet size is between 0.4 to 0.5, depending on the buoyancy, depending on the floating rate of the materials. Here are some comparisons between the extruding particle and the crumblers. As you can see here, you see here there are a lot of shining things on the surface. It's the fines. We can see very clearly under the microscope. So comparing with the crumbles, you can see the extruding microfeed have less fine, and the surface are much smoother and better uniformity, which is good for the water stability, which is good for the baby stream and fish. This is a comparison between the extruded feed and the sterilization stuff. Again, the uniformity is much better than the right hand side. pictures. This is the comparison of starch density degree according to our measurement. For the extruder, you can easily get between 70 to 80 percent starch density degree. But for the spiralization, because the heat energy and the mechanical energy input for spiralization is pretty low, so the starch for the cooking of the protein is pretty low. Okay, so this is a short video showing that this is shows that we're doing the test using our pilot line in our test center. Every year we collaborate with our customer, to join innovation, to join develop the new product closely. No matter it's normal size or macro size, no matter it's aqua or Petfood. Next time, if you have this requirement, please welcome you to Function Test Center for further discussion and for further development for your new product. That's all I would like to share today. Thank you.
I know it's a long day, but the longer days will come tomorrow and the day after, for those who are also exhibiting. And I'd like to take you today a little bit on the journey on versatility of extrusion systems, of what we can do, where is the challenges, on what we have to watch out. I think we heard today a lot about the traditional fields where the area is going, we heard a lot, and I also like to take a little bit of a look on where is our challenges as an industry in PET and in aqua. I mean, those industries are very, very, very cost driven. So production cost is at the moment, we hear from many, many customers, production cost is their challenge, no doubt about. We have climate change, there is digital products which come into market, the customer don't know what to do with it, how to deal, what to convert, and how to really get the benefit of it. Then eating habits change, tension change, geopolitical stuff with Vietnam, Ecuador we heard today. So the markets are changing, premium shrimp get moved around, cost advantage of fish meal in Ecuador, Vietnam get tariffs, Thailand get tariffs. So there is definitely a lot of ongoing things we need to think about, half step ahead. Animal disease, antibiotic reduction also come now in Asia, but also energy cost is very probable to be a problem in 2025. We saw last year in China, our Chinese friend, they know what happened when the coal gets short, so the power price goes up. So we ask ourselves the question to start to look a little bit from a different point of view, and we start with looking from a carbon footprint point of view to the aqua and PET industry, and we quantified a whole process line. How does manufacturing look like from raw material to transportation, manufacturing, distribution, and said, yes, this is the way we have to look at it. And our major contributor inside of that game is electrical energy. So we have to be fair enough, we are a part of the polluter game. So we also have to think about, when we break it down, we have to all the time ask ourselves, do we ask the right question for the problem? And the first thing is, when we cannot ask the right question, we have to get a little bit data for help. And this is what we have done. So definitely the major focus should lie in grinding and should lie in drying. So those are the two major contributors into the game, and those we have to tackle. There is many different ways how to tackle that. We heard a little bit about soybean. Soybean definitely is a very hot topic, but there is also other topics, especially in raw material, we come afterwards into it, where we have to look from a cost side point of view, but also from a CO2 point side of view. CO2 is equal to cost, energy, money in the end. It's about cash, where when you run a PET or an aqua plant, your biggest cost is raw material. It's not capex. Your two biggest cost is raw material and OPEX.
CapEx is more or less forgettable in the long run of a 10 years cost. So we really have to think about how do we address those. Definitely we have to work on the machining industry. We have to, like all the machine supplier, you have your novelties, you have your innovation. These will enable future innovation. We have to talk on grinding system. So Bühler also worked with his new hammer mill. We worked there on how to grind better, finer, more energy efficient. I think there is many, how to say, functionalities what can be added. In the end, everybody cook with water. So we have to be aware that the soup still has to be eatable. And as long as we have this in mind, everything will go well. But as well, we have to think about drying technology, where we have to go with smart drying. How do we make that things more automatic, more assisted? I think the people are the bottleneck. The technology is never the bottleneck. All the time, the people struggle with how to adopt what we have done. But also, we see a lot of new raw materials inside of the industry. So we see, for example, insect meals coming. Good protein content, not hard to manage. The problem is how to get for what the cost. It's very, very depends. So in Europe, at the moment it's good. Northern Europe also quite okay. Depends a little bit. So in China, South China, possible. Southeast Asia, not really. Then we see a lot of algae. It can be seaweed, it can be algae, it can be microalgae. We have innovative customers, for example, in Italy, they use wastewater to grow microalgae. Microalgae is about 65% protein content. Very good raw material from a wastewater point of view. You have the glass tubes, you make your raw materials again. But also single cell protein, especially US is very leading in single cell protein. But also fermented soybean meal is a very interesting approach, especially when we ask ourselves the right question. It's not about protein content, it's about how many amino acids you have in what kind of a balance you do. This is actually the right question. And we have to stop to think too much about protein, we have to start to think about in amino acids. But also there is a new form appearing inside of the industry. All the raw materials become wet. And then you need to think about how do you manage liquid algae slurry with 50% moisture content, medium to high viscosity. We have fresh meats, animal byproducts, especially in pet, very, very famous. Then single cell proteins, normally liquid, it's kind of a soup, like soldier fly soup. How do you need? So they are very interesting for our customer when we remember the picture of the CO2. The biggest cost is raw material. If you don't have to dry your raw material, you have an advantage. So drying costs money. So if you need to dry your algae to powder, it costs money. If you can inject liquid algae, already 1/3 of the product cost gone. So we have to think, how do we local, how to think wet, how do we manage all of these slurry and soups inside. So this will be the future. So that's why we have to designing systems which are capable to manage, where we can pump into conditioner, into extruders, where we can pump all those variable slurries inside in a different sequence. Depends. Is it oil? Is it protein? When does it coagulate? What kind of viscosity does it have? So we pump all of this muscle meat, all kind of organs, slurries and mixes, and inside of here, do we have to preheat them? Do we have to heat them up? Do we have to just pump them cold inside? So this is things where we need to manage. For example, when we go in pet food, so this is the way to go. So chicken slurry, directly heat it up, directly pump it inside of the extruder conditioner, and then you can, of course, you come with about 60-70%, and then this is how you come up. So the question is not can or not. So the question is how stable it is, how long you can run, how do you manage the fluctuation, how you go with this consistency ahead of all these variable materials. So it's in a simplistic point of view, powder is very simple. As soon as you start to add liquids, accuracy, all of these start to matter, and consistency start to matter. So in the end, you will come to the point, Do I go with single screw? Do I go with twin screw? And I all the time said, it depends. So it depends what you want to do. So we say low medium fats, we go with single screw, protein inclusion, mechanical energy input, clear. The pro of a single screw, definitely it's less capex, no doubt about this. So we are all, how to say, everybody cook with water, it's just steel in the end. And when we go with twin screw, when we have super high, when we have protein, when we really need a lot of flexibility, yes, let's use that tool what we have. So that's why in Japan, all the Aquafeed extruder are twin screw. So Japan is one of the leading also with how do they manage all these local products from one island to another. They do always twin screw, so they're very high flexible, very high, easy to clean, very good in terms of that. Also, when we look into drive, pet food nibble, so for example, when we go with dry nibbles, single screw is definitely okay. If you go brown, semi-moist, fresh meat, co-extruded into treats, sure, twin screw is the way to go. But also, we heard earlier, so we have to think about features, we have to think about density control, and density control is a normal kind of mechanism, and we have to add this onto our machine, which enable things to be constant. A customer to either innovate in terms of new products, but also they innovate in terms of how to bring the quality to the next level. So how consistent they can run. But also intelligent extruder system like control system for extruders will definitely enable innovation. And how does this enable innovation is, I have a good friend, customer in South China, he told me, Philip, don't save me the people. If you save me the people, my people no time to focus on quality. So many people think, oh, people is money, but in the end the question is how you differentiate in the market. Have to think about if you have a control system which does SME control automatically, bulk density control, conditioning control, everything full automatic, your people has more time to focus on what matter for you. SME control with elements, we do directly inside on the extruder screw, we adjust according to the needs. Also, especially when we go in liquid additions, we have to consider that. This is definitely the way to go, where we can control different expansion rates according to customer needs. But also, we have to help to inform the people. So, there is a certain critical control points, we heard earlier from Samsung. We have to pay attention into the manufacturing. The point is not that there is. The question is who knows and who takes care. And we have to really work on how do we integrate the people inside of our extrusion system, how to make this happen to ensure quality, especially for pet food. We had a lot of complaints, if I remember well, it's about 200 food security alerts last year, with about 2,000 incidents around the world just for pet food itself. So that means meat pass into the system which had not a required temperature. There was in 2002, I don't know how many 100,000 animals passed away due to somebody didn't properly adjust the machines. When we look into shrimp feed, I think there is many things possible. So in the end we have single screw, we have sometimes twin screw, but I think all important is also what kind of conditioning system we set above. Conditioning system is very important due to we properly need to hydrate the starch. Recently, especially in Southeast Asia, we have not a uniform material. Indonesia have local corn, Thai have local corn. Local corn is not stable, so we have to hydrate the starch. Depends our raw material we have to hydrate. If we don't hydrate the starch properly, we get resistant starch. So everybody who is from food industry will know, okay, people, we like resistant starch, we can eat a lot and not get fat. For the animal it's opposite. They eat, but they not grow. And we talk gelatinization degree is important, but resistant starch will be the word of the future. RS3, for those people who interested into it, animal conversion rate is heavily reliant on resistant starch. We heard about microfeeds can be done in a different way, and I think this is the way to go, and we have to keep the people the option. There is no change from today to tomorrow. It will take time. Depends the raw material formulation, the way to go. I think the way is we have to adjust our systems that it's capable to produce in any case. There is not right or wrong. There is just a question of how the raw material availability, how much flexibility does the people need to get it done. Also, this cold extrusion is coming more and more. Also, long hydration times is coming. This high open die area, I think we heard a little bit about this. So when you're enlarging the die, of course you can go with more capacity out of it. Everybody is clear about that. And then we have to think also, we have to pressurize the head with the big die area together. We can sometimes double the capacity. So we know, example, we more than double the capacity with just making the die bigger and pressurizing the head just to stabilize the environment. So this is things what we have to consider. Microfeeds is the way where the industry is differentiating. Also, so with us, I think we have to enable the farming industry. China is a leading manufacturer, and all the time what makes China interesting is they commercialize first. So they study hard with the university how to make things happen. Then afterwards it's a question how to commercialize. And I think that is the point where now Southeast Asia also can learn from Big Brother. Also, how do we commercialize? Where does it get independent locally to really get track on the system? So down to 0.4 is not big issue anymore. So this is the way to go with the right extruder together. But also, we have to think there is still a lot of customers that run extrusion systems. But also there is a lot of customers that run pelleting systems. How do we improve pelleting? Major operation cost in pelletizing shrimp feed, for example, is binder material. Binder cost really high. So the question is, how do we can gelatinize some starch? We heard about this morning, 25% starch in pelletized feed. So the point is, how do we reduce that one? We just have to make the starch right, in the right form. Make a good viscosity, cook the starch, it works like a glue. Stitch the stuff together, make your own binder inside of your plant yourself. Very simple, with a single screw extruder, very simple to do, very simple to be done. When we look into application of slurries again, slurries are also in food industry. Cereal, we heard about banana and mango slurry, we inject meanwhile into cereals. We also injecting sprouted grains inside of TVP, but also vegetable slurries, tomato, spinach, everything from the farm, just grind directly, make it inside of your high moisture extruder. Especially pet food industry is there half step ahead, while they are the master in managing slurries, especially meat slurries. Also the meat slurries, they come inside with pillows, but also with high moisture extrudates. Also, the cooling dice does not stop. Cooling dice is a good tool, especially for pet. Pet has two trends. One is the treats. The treat market is nearly similar size as the premium market in certain countries, and pet food also becomes sometime plant-based, but also mixtures. There is not the world vegan does not exist in pet food. So the point is, what kind of mixture you're going to run between meat and proteins. Also, there we update the industry, so we are not stopping, we cannot stop with innovation. So we are, for example, improving texture with breaker plates. We go to update the texture so that the meat analogs get more muscular style, also fish style. Then we go with different temperature zoning inside of these cooling dice, really to make the texture, also for the animals, if they just swallow it down, then this is not the way. So pets are very sensitive on textures. But our customers are also very sensitive, not only on textures, also on money. And we learned, for example, you can aerate your high moisture extrudates, but you can also just add a little bit air to save cost. So this, by the way, the chocolate industry is very good in that, so they add a lot of fluffy rice cake crispies inside of the chocolate. Like this one, the chocolate bar costs the same, but the package looks double. This is the way how it works as well. So pet customer now, the market is not as booming as it was. It's still good, it's still positive, it still grows, but competition is getting harder. And in the end, who buy the pet food is the people. And the people, if you get double the size, you will buy double the size for half the price. As well, when we look inside of this aeration technology, this is really how then it comes out. When we put all together with aeration, with breaker plates, then tuna, nowadays no question anymore. So there is more or less no differentiation anymore, which can be distinguished. Where the pets now, there is big European pet food manufacturer, American pet food manufacturer, which are in early launches of their product, not only due to their CO2 footprint, whatever, it's also cost and the manufacturing efficiency out of it. But also multicolored pet food, bicolored pet food, still we see this is how the industry innovates to differentiate. So also filled pillows we see often, sometimes with liver inside, sometimes with meat inside. There is many different kind of where food and pet food industry merge together. So the people do understand what the pet should eat. The pet, they don't care. It's a pillow or whatever, so they care is it crunchy and how much I can get. So this is pretty much incentive driven, but the people like to buy it. Also, treat dental sticks is a very, very big growing market which has to be addressed, and there is definitely a lot of innovation to come. But also, there is actually no limit. When you have an extruder, when you're manufacturing all your raw material, your extruder, right, it's all what comes out of the die. It's afterwards how you take it from the die further. It's just a little bit, you need the right partner. Also Bühler, we does not do that all ourselves. So we work with partners, with an ecosystem which can help you to do that. Same like we do in the food industry, we have to do that into the pet industry. So everything starts with an application center. Normally ideas are generated by I know what to do. So it's join together, get the right minds together, and when you're getting the right minds together, then this is the way how ideas are commercialized, how they are done together. And with this one, I want to say thank you. I'm on the fast side today, due to I want to give you enough time for question, but also for networking. I think today we should not only sit here, and we should also be active and have a coffee together and a good chat. Thank you.
Good afternoon, and thank you to be here. So PLP is a company based in Italy. We manufacture applications for liquid and powder handling. So whatever concerns the spraying, mixing of liquids, or microdosing of powder additives. And today we will be talking about the continuous coating in atmospheric, where we can increase the quality of your product. So we have to understand what is the scope of the coating application. Coating in pet food and aquafeed is in general used to increase the oil inclusion. So when you have limitation of adding oils in the production, increasing palatability, preserve the feed and the food, and adding heat sensitive nutrition on the product. So in the market you can find different technology for applying the liquids on the pet food and the aquafeed. Typical is a batch coater in atmospheric. The batch coater is considered a bit of like a simple solution because You are weighing the product, the kibbles, the feed, you're weighing the liquid, and you are spraying this liquid into the batch fix. It's a bit of an outdated technology, mainly because you cannot achieve high homogeneity. Let's say that if you're adding 10% or more liquids, batch coating could be an option. If you are adding 5-6% or even less liquid addition on a coating application that is working in a batch system, it would be difficult to achieve high homogeneity. So the quality of the feed could be not, let's say, it would not be uniform this way. The other technology as a batch system is a vacuum coater. This is the only technology that will allow you to apply high quantities of oil. When you're talking about 20, 25, 30% of oil addition, this is the only technology that you can actually use. Instead, what you can find normally in the market when you're talking about continuous application is the drum coating. Very wide use, especially in Asia, but all around the world. Also, this one is a bit of an outdated solution because mainly the main problem with the drum coated application is achieving a high retention time. So letting the oils that you sprayed on your keyboard to penetrate into the keyboard. Another technology used is this coater. So here you will have a higher mixing effect of the product, of the oils. You can have a good retention. The problem mainly on a disc coating application is the build-up of dirt in the disc. So there is a rotating disc where oils are applied, and this can generate a lot of build-up of the dirt. So what is PLP doing? We have a coater system, continuous coating system, we call MT machine. Is a twin shaft continuous paddle coater where we apply the liquids in a different way using a motorized sprayer. So this type of mixing is very gentle, so we're not giving a lot of energy through the paddles to the feed. We are mixing it in a good way, but without damaging the product. Spraying, you can see it here, this point, is done on using motorized sprayers, directing the liquid applied directly on the keyboards. This type of technology allows us to spray from 0.01% up to 15% of liquids and powders. So system used also for spraying probiotics, enzyme, or other microelements with a very, very high homogeneity. Consider that we have application running at 0.01% addition with a CV of 5-6%. So with this number, it's a very good result. We can have a different additional stage. So first could be an oil, a fat. Second stage could be a palatant. We have a special retention valve internal to the machine to keep constant flow and increasing the retention time of the mixing effect. And also it's a very easy machine to clean. So it's not a big machine. We have top lids. Cleaning is very important, especially when you are adding water-based product or other liquids into your onto your keyboards. So what do you need when you want to have a good continuous application? The first thing absolutely is to have a performing dosing of the feed. So you want an application that can dose in a gravimetric and a continuous way, and important that you should have also a smooth output. So if you have the food coming out of the dryer it could be inconstant, and you cannot have this inconstant flow into your into your coating system. So it's important to, before entering the coating application, to regulate and stabilize the flow rate of the product. Secondly, of course, is the coating machine. So the machine should be gentle, but also having a good homogeneity mixing, and also have a retention time of at least 60 seconds in order to allow the liquids to penetrate in the food. The other most important thing on a coating application is obviously the spraying. So when you're talking about continuous spraying with the high variation, so some formulas can be inclusion of 1-2% of oils, and the next formula could be 15% of oils. This could be a challenge with the standard nozzles. For this reason, PLP uses the smoke technology, the motorized sprayer, that can allow high variation of flow. So if we look at the first point, accuracy of dosing of the keyboards, we offer 3 different technologies. Gravimetric bed feeder with a very good accuracy, less than 0.5%. It's very gentle, and it's also a system food approval. So it's easy to clean. Normally this type of weighing system, we would use it in food application, for human food, but also in pet food. Second machine that is widely used is the gravimetric screw feeder. So it's not a loss in weight technology, it's an actual gravimetric screw feeder. Accuracy is still good for a continuous application. It's a closed and compact machine, and it's suitable for products that are dusty. So this is largely used in pelleted feed, poultry feed, crumble feed, for example. Then we have also a gravimetric plate. This is normally used when there is limited space in the production line. Otherwise, the two preferred application is the bed feeder and the screw. We have different models depending on the capacity, depending on the product, depending what you need to achieve. If we're talking about industrial coating application, pet food and Aquafeed, we normally have supplied these 3 models, MT30 XL, MT50 and MT100 with variable true hoods. They also include heating jacket to the machine, and they can exceed high retention of the product. So this is a section of our application, the machine, how it works. We have the continuous paddles rotating, creating like a sort of fluidized bed on the top. And we can have different positions for the sprayer. One here is in the center, one here one is on the side. The important thing is to spray the liquids on the feed, on the food. So avoiding spraying liquids that can hit the paddles or can hit the side wall of the machine. If this happens, you will have build-up of dust, lumps, dirt, and mess. This is a typical layout, mostly used pet food, but same also for the Aquafeed. Buffer hopper for level control. Here is where we're controlling the input coming from the dryer, the cooler sometimes. So if the product is coming continuously by inconstant, this buffer hopper will help regulate the output of the feeder to have a constant flow inside of the machine. We can have a liquid application for multiple liquids, oils in general. If you have more than one oil, we homogenize and then spray continuously to the machine. Second liquid can be a paratant, hydrolyzed, aroma, whatever. A big difference from a batch application is the total height, the space that is required for installation of a continuous coater. So normally if you have a batch system, between the buffer hopper on the top, the mixer and the discharge hopper, you probably need at least 6 meter high. With a continuous coating application, you can have a system installed in less than 3 meters height. So this is also giving an idea of saving height in the building, saving energy on bringing up, conveying up the product to feed the coater. Also the motors, the power used in a continuous application is much lower compared to a batch application. So if a batch system typically can go from 12, 15 up to 22, 26, 36 kilowatts depending on the batch size. Our continuous application, we have the two different sizes. One is 8 kilowatt, the other one is a total of 11 kilowatts, so much lower energy. We have also on the machine heating jacket, so we create like a warm ambient where the keyboards are mixed in. This is important for many reasons. One is obviously keeping the oil as low viscosity as possible in order to have a better penetration of the oils in the keyboard. Second is to avoid the fat to stick on the wall and creating the mess that we were saying before. And another important point is avoiding condensation. So if you have keyboards that are coming in at 70 degrees or more, if they find a cold ambient here, they will start evaporating, creating water inside of the coating. Okay, you can see a few pictures of installation. This is the internal view of the machine. This is instead the buffer hopper with the weighing belt, the coating machine, the liquid application here at the beginning, and in this case we have two powders. You can see here the cover for cleaning the machine, for inspections, very easy. The machine is less than a meter high, so easy to clean and to maintain. So when we a way to increase the performance of the coating application, one, we said it before, is the heating chamber, so keeping the machine warm. Another solution is to adjust the angles of the paddles in order to increase the retention time internally. This obviously is done manually, generally done the first tap of the line. Adjusting speed of the rotation of the shaft. So we have the two shafts with independent motors, each motor running at different speed, one higher, one lower, to create a more mixing effect. And this speed is also adjustable during the production. So if you can link a certain speed to a formula, to a size of keyboard, to a size of density, and a different speed to a different size of density. This is to have a more mixing effect, or even to reduce the impact that the paddle could have on some special shape keyboards. We also have internal dams positioned near the spring point, so these dams are creating like obstruction of the feed coming out, moving forward, so to have a better mixing during the spraying. But what is the game change of this machine is automatic retention hatch. So this is the valve internally to the machine, fitted inside. It's self-leveling depending on the flow, depending on the level of the product inside of the machine, and it's used for two scopes. One is to increase, obviously, the retention time of the product that stays inside of the machine. That is in generally about 3 times more compared not to having this type of valve. So we can reach up to 240 seconds depending on flow rate and density of the product. The other reason why this automatic retention hatch is a game changer on this type of machine is that it will allow to run the machine always full. So the issue with the continuous application is that machine is designed for that flow rate, for that capacity of the line, and not good for other type of capacity. With this valve, we are regulating the quantity of product inside of the machine. So let's say if you have lesser flow rate, less production capacity, you will have an increase of retention time of product. This is important so not to spray the liquids onto the machine, onto the paddle, if the machine is running nearly half empty. Obviously, another way to increase the homogeneity, to increase the retention time, in order to allow addition of more oils, is having 2 coaters in cascade. So we have application in pet food where we have been reaching 18% of oil addition, thanks to the retention valve, thanks to many things, and also thanks to the second machine in cascade. This is also very used when you need to add many different additives on your feed or pet food. Typically the oils, the powders, hydrolyzed powders, and so on. So when you have formulation with many liquids, it's commonly to see customers that are applying soy oil with fish oil or palm oil with chicken oil, a combination of different liquids. We always recommend to blend these liquids before. So typically these liquids would be added separately, first the soy oil, then the fish oil, but soy oil is maybe a light color and the fish oil has a darker color. So when you apply it on the keyboards, this could give a visual bad image of your feed, because you can see a darker feed, a darker keyboard and a lighter keyboard. So we have this machine we call it dosamic system. We are pre-batching the liquids, small batches, micro batches of liquids. We homogenize with a high shear mixer, so we can even add water-based liquids. We have customers that are adding, for example, antioxidant for the oils, or aromas, lecithin, and so on. So we unify the liquid and then spray in continuous on the coating application. So we were saying before, I mentioned before, the hydrolyzed liquids, the digest. These are very viscous liquids, also quite smelly, and they're used for improving the intake, the flavor of these keyboards. So it's also quite normally expensive additives, and you want to be sure that when you're spraying these liquids that are normally in a range of 0.5 up to 3, maximum 4%, so small quantities, you want that this product should be evenly distributed on your food. The other issue with this liquid being so high in viscosity and with sometimes impurities, it could be that your standard nozzle, if you're using pressurized nozzle, will not be able to use this to spray this type of liquid. So even in this case, the small technology that PLP uses can have very good benefits. So this is the smoke sprayer that is applied on the beginning of the entrance of the of the kibbles into the coating application. We don't need high pressure, so you can use any kind of pump. It works by centrifugal forces, so we are spinning a cone internally where the liquid is passing through. We have injection nozzle of 9 millimeter, so no dirt will block the nozzles and no impurity will block the nozzles. We can also have a solution of powders mixed into a liquid and then sprayed. And the good thing is can range from 0.01 up to 15 liters per minute. So it has a very, very high variation of flow rate. Powder spraying is also very important, mainly in pet food, but also it's getting common in aquafeed as well. Pet food typically is the aromas, the palatants. Some customers are using also applying powders in, for example, probiotics or enzymes. In aquafeed, probiotics also very important to apply them after extrusion, so to preserve the effect of the probiotics and the enzymes. So what we are using here, we actually have different technology, but they're all based on loss in weight dosing. So small screw feeders that are able to dose the right quantity. And the powders are not only dropped into the coater, they are actually sprayed. So we are using a Venturi reactor in order to nebulize this powder, and when possible, so depending on the characteristics of the powders, they should be less than 50 microns inside, we can apply some electrostatic forces. So this will have a better distribution and a better coating of the powders onto the kibbles. In aquafeed also what we are working with a lot, when obviously the addition of oils are very high, where you absolutely need a vacuum coating system, is to apply some special products, vitamins for example, or sensitive products that can be in powder or liquid form, after the vacuum coater, after the cooler. So this is a top coating from your existing coating. Also here, we generally using a dozen mix system, where we are adding together with the different liquids, it can be a palatine, an oil, water-based product, and so on. And we can add some also powder solution, homogenize, and then spray in one go onto the pellets. So this was all. I hope it was clear, and in any case you can come and visit us. We have a stand here in the area. Thank you.
This talk is about using the blood plasma in the pet food. There's a lot of interest coming up where they want to use a fresh meat in the pet food industry, and Extrusion technology, but also they want to use some of that blood plasma for several different reasons. Therefore, just to give you some background, we have seen supply chain disruption because of COVID, and also we have increased that there's demand for the high quality ingredients for the pet food. We heard about pet parents, and of course the parents want to treat their pets in very high quality ingredients, and also we saw that we were looking for the ingredients which has some low environmental impact. We heard a lot about sustainability, and that created many challenges in the animal feed and the pet food industry, because in the past decade we've seen a lot of issues, especially the supply chain and all the things that happened with that one. And humanization of the pet, desire very high quality food for the dogs and the cat, and everybody want to feed their dogs and cat the same what they are trying to eat themselves. Demand for the highly digestible, palatable, and biological value ingredients has created challenges and opportunities. Challenges are for the pet food industry, they have to make that one, and that opportunities also because they can make some more money from there. Therefore, this is like you have to find out the ingredients and then of course see how can you use it. Therefore, some background, there's, as mentioned, increased interest in the protein ingredients that have some functional properties that can also meet the nutrition requirements, optimize the health of the pet, reduce the environmental impact, and some of the functional animals and plant-based ingredients have the potential to meet these challenges, and one of them is called spray-dried animal plasma is one of them that can be used in this application, especially to meet the need for the pet food. So what is the blood plasma? Basically, plasma is that's a liquid portion of the blood containing a very rich mixture of the proteins, bioactive compounds, and nutrients. And of course, it includes the vital components like albumin, globulins, all that proteins which contribute to its functional property. That's what they're trying to use that in the pet food. And spray-dried plasma basically where it's not that simple that you can just take the blood and then of course spray-dry it. It does take a lot of processing of spray-dried plasma, and I will walk through there quickly how that works. Context of the pet food plasma is processed through the techniques such as centrifugation and spray drying to ensure the safety as well as stability before you can be used in some of the applications. So how do you make that blood plasma basically? This is, as I mentioned, co-product from the pork, beef obtained during the processing of animals for human consumption. And then of course they add some anticoagulant added during the blood collections. The blood is centrifuged to separate the plasma and cellular fractions, which are called red blood cell. And these fractions are subsequently spray dried into the powder form. This processing system maintains solubility and functionality of the ingredients when added to dry or wet pet food for the dogs and the cat. So basically, this is the way we process that, and I'm going to go through there step by step. Spray-dried plasma produced from, as I mentioned, porcine, which is called spray-dried porcine plasma, bovine, spray-dried bovine plasma, or poultry, mainly chicken, that is spray-dried chicken poultry blood. Commonly used for the human food as well as any food. Believe me or not, they are using also some of that also in the human food as well. And the commercial production of spray-dried animal plasma basically adhere to the very strict good manufacturing practices to ensure the production of the safe and high quality product. Spray-dried animal product is produced from fresh animal blood from veterinarian inspected animals, and they have to determine by slaughterhouses that they are good for human consumption. They are not disease animal, they are not, some of their health issues. The veterinarian check the animals before they slaughter it, then they were able to collect the blood. And blood is collected only from the intact carcasses so that they can prevent the contaminations, and it handles separate system from the carcasses processing chain. And then of course that's treated with the anticoagulant, and of course then refrigerated immediately 3 to 5 degrees C, and then of course it's pumped into containers and directed to a centrifuge for further processing. Therefore it is like a food grade. You can see it operation there, good quality manufacturing. And then of course blood is separated into the plasma, of course, and then using centrifugation, plasma is then concentrated, refrigerated 4 degrees C, transported in the sealed tanks to our processing plant, and after use all the storage tanks and everything has to be washed and cleaned and sanitized so there's no cross contamination in it. Then it goes into the spray drying facility, and that in this way they will do it industrial spray dryer, which rapidly concentrate and dry the blood plasma into the powder. In most cases, prior to dry, also they use some kind of evaporation system or membrane system so that they can also reduce some of the water. Spray dye consists of atomization of liquid feed materials into the steam heated, resulting in the rapid desaccinations, and then of course plasma is spray dried under high pressure around 80 degrees C to convert into the powder. And also the whole system is monitored, controlled by procedure to ensure the safe quality. They have fully automated system, monitoring records, everything like that. And after spray drying, each batch product is basically individually identified, packed, and tested for that, make sure there is no any contamination in it. Spray-dried plasma produced from the blood, we talk about it, and its production flow strict good manufacturing practices, and then of course the fresh blood and veterinarian, just to emphasize that. So these are the steps that you take it to make that one. Veterinarian inspected for the animals, then of course you separate the plasma from the blood, and then of course you got there also ingredients added from the coagulants, transferred to the processing plant, pumping into the industrial spray dryers, and then packaging, and then of course safety check, all that. Therefore these all the steps take place to make the blood plasma. And again, this is just to show you some of the pictures. You can see there one, how they're producing that one from the raw materials, centrifugations, membrane systems, drying their blood plasma, all that before it goes to that pet food industry to use into the pet food industry. Therefore, why do we want to use it, blood plasma? What is the functionality? What is the benefit of that one? And some of that functionalities and of this blood plasma is that it's basically a very innovative application in the pet food production, offering nutritional and functional benefits. Derived primarily from the blood of livestock, we talked earlier, powder form, and also the safety is incorporated into the pet food. Number one is that it provides very good palatability, and it's highly palatable for the pet, enhancing the taste, smells of the pet food. It's a natural umami flavors that appeal to the dogs and the cat, encouraging them to consume their meal. This make plasma particularly useful in the diet for the picky eaters of animals. If your dogs and cats, they are very picky, if they have used some of the blood plasma, and that basically will help them. And also animals who are recovering from the illness, people are using that one blood plasma there to improve their also health benefit there as well. Also, there is a nutritional supplement. This is a rich source of high protein. Also have a very good amino acids essential for the growth, muscle maintenance, of overall health in the pet. Contain bioactive compounds that can also have a support immune system there as well. And also it's good for the good health, gut health and digestive support. And basically the functional property of the plasma help to strengthen the gut barriers, support healthy digestions. Studies suggest that the plasma protein can reduce your gut inflammations, improve nutrient absorptions, making it more beneficial for the pet. And with the sensitive stomachs, and some of them they have a gastrointestinal disorder, then you can use that one and help that. Also, it is a very good functional ingredient in the wet pet food if you are making it, because it's an excellent emulsifying, water binding property and make it versatile ingredients in that wet pet food. It helps maintain the texture, it helps maintain the consistency and the moisture, improving the overall quality. Most of the canned pet food, when you see it, they will be using it also, a lot of blood plasma there to improve their functionality there as well. Also, this is the alternative protein source. As the pet food industry seek for sustainable, again, protein alternative, plasma offer a valuable solution. And of course, it uses, help minimize the waste in the meat processing industry, while providing a very high value ingredients for that pet nutrition. Therefore, basically, it reduces your carbon footprint as well, because you are recycling all that which is going to go waste from the slaughterhouses. You're collecting them, reusing them, and then of course making them more for the pet food. Other benefit is that also is the digestibility, highly digestible, and can improve the digestibility of the others nutrients in the pet food. It's packed with a high quality protein which pet can easily digest and make use of that one. Also, it contains some of the bioactive compounds such as the growth factors, peptides, which can promote wound healings, enhance recovery, and support immune system. Particularly useful for the therapeutic specialized pet diets. Therefore, a lot of people use that, especially blood plasma in that kind of diet. Some other nutritional properties, if you can see that, inherited solubility, functional properties of plasma are maintained after manufacturing. You don't, because you process centrifugation, membrane system, spray drying, you don't hear too much heat treatment. Therefore, you still keep all your functional properties there. And of course, plasma as a fraction of the blood, animal blood, very nutritional, rich ingredients, and of course the high concentration of essential amino acids, and it also confers the biological functionality there as well. And you can see here some of that benefit, just to summarize that, some of that. high amino acid concentrations, aminoglobulins, bioactive peptides, growth factors, enzyme, also peptides, anti-inflammatory, and some of the other neuroreproductive properties also there as well. Also, spray-dried animal protein plasma have used in extruded pet food. If you know that most of that, it improves the textures, palatability and digestibility, and also it can help with the water retention and juiciness and homogenization. We saw recently trend that most of the consumer want fresh meat. We heard earlier also somebody was talking about here, I think the buller, that we will want more and more fresh meat. Fresh meat, when you add that in the extruder, it becomes some kind of challenge because it is 70% water, and sometimes we have a lot of challenge comes in. And of course, we have to overcome with a lot of challenges when you use a lot of fresh meat there, especially depending upon how much fresh meat you want to use it, 30%, 50%, 70%. More you use it, more challenge you have it, because this comes with a lot of water and also some of the fat, the fresh meat. Therefore, it's not sometimes practical to use a lot of fresh meat unless you have some other strategy, special extruders and also preconditioning. But also, in this case, this blood plasma can help as well. Traditionally, spray-dried blood plasma has been used in the wet food most of the times to increase the water holding, binding, fat emulsification. Now recently research showed that if you use only 2.5 to 10% your just blood plasma in the pet food formulation, you can increase your 45% increase in the fresh meat. If you are pumping your fresh meat slurry we saw earlier into the extruder, and if you can also mix with that around blood plasma, you can increase your fresh meat also there around 45% in the pet food as well. Also, it helps to form the structure of the forming agent. Plasma is highly solubility and composition make it likely structure forming agent in the extruder. Pet kibbles, if you are extruding the pet kibbles, you are basically making a treats, and it will help you set the structure there very nicely as well. Therefore, to summarize that, there's a benefit of using blood plasma in pet food. We can have promoting, of course, that their intestines, morphology, enhancing the growth, increasing that, of course, our feed intake. We can also have some other benefit there as well, and enhance the health, and therefore there is quite a few benefit comes with that. And of course, some technical benefit we get from there. Of course, the source of proteins, gel strength, fat emulsification capacity, water holding capacity, standardization, the quality of the final product, improving digestion, increasing palatability. That all the benefits comes with that if you use the blood plasma into your pet food as well. Also, use of plasma in the pet food is regulated to ensure the safety and ethical sourcing. Additionally, incorporating plasma aligned with the sustainability goal by reducing their byproduct, of course, the waste in that meat industry, which usually goes that. Therefore, it also fulfills your ethical and also responsibility did that one. Also, it is safety is very important for that pet food, because most of the pet food are fed with the kids when they're playing with the pets. They want to give them pet treats, and if there's some contamination there, it can have effect on their health as well. Therefore, basically manufacturing follow very strict protocol to collect and process the plasma hygienically, eliminating and any of the pathogens or the contaminant there. Prior to being related to the sale, rigorous quality control work is done, test is done to make sure there is no any contamination into that one. Product batch numbers allow traceability. You can trace that where the product coming from. So if there's any recall, any of these things, you can always go back and you can follow up with that one. There are some future opportunities that comes with that blood plasma as well. Use of that spray-dried animal protein in the dry pet food open new opportunity. Pet food producer can develop a diverse and new concept, such as using that improve their cognitive functions, and of course mobility in the diet oriented in of course the senior pet. Additionally, this is the opportunity to use spray-dried blood plasma in veterinarian diet, pet with that some of the gastrointestinal disorder, and companion animal which is also have inflammatory disorder. Therefore, these are the benefit of the future. You can see the opportunities the pet food industry can use it if they are considering using this spray-dried animal blood plasma. Future opportunities, again, here is that due to the we have prebiotic effect of the spray-dried animal protein can be used in some of that puppies and kittens, can help develop a benefit of biota in the early life stages, help pet develop a strong, healthy gastrointestinal tract, also binding properties, may help develop the dry pet food, and also increasing the fresh meat, maintaining the physical property of the dry kibble. These are all the benefits which you can see coming up in that opportunity with that. To conclude that, plasma is a multifunctional ingredient with a significant benefit for the pet health and the pet food quality, from enhancing palatability and nutrition of the supporting digestion and immune function. Its applications are diverse as well as impactful. With that, just to conclude again, is the pet food industry continue to grow, innovate. Plasma stand out as sustainable, nutrient-rich solutions that will control your well-balanced well-being of the pet, monitoring environmental responsibility through thorough, careful sourcing and processing. Plasma role in the pet food is poised to grow and offering pet owners an effective way to promote high quality and nutrition their, of course, their furry companion. With that, thank you very much. And if there's any question, we'll be happy to answer.